and then if you took if you took the images from all of those and tried to stitch them together, it wouldn't work. It would make like kind of like that plane window animation GIF that we share. It's like pick A, B, or C, and the middle one is kind of like arches. Right, from every lens you would see this arch, what looks like an arch, like a concave section of Earth, and if you stitched them together, it wouldn't form what would be a globe. So I think there has to be some kind of other effect in place. Does that make sense?
Yes.
Only if it's at eye level or very low or very close to it.
Well, the camera is the eye level.
I guess, I mean, not even really, Dan. I mean, because like I've showed this before, like on a yoga ball, you get your camera lens right down on the surface and center possible, right? And then just turn it around while it's vertical, its axis. And you'll see every point, every way you turn, it's just showing that. But you don't stitch the yoga ball together and it has like flower petal surface.
That's the problem. So that means that as you rotate, you'll see, say you're rotating right to left, as you're rotating around your yoga ball right to left, on the screen, it will look like it's got a slight like a parabolic arc that's been laid over. That's the effect. That's an extreme version of what happens. It's just got a slight bubble in it. When you look straight ahead, if you take a snapshot, it looks like it's arced. But as you move, and you've got, say, 20 of these cameras.
I think they're a flat Earth.
Yeah, fucking oath, mate. Nice of you to start your sentence in the middle of mine.
Sorry. Because I didn't hear you. My internet is slow, so I didn't know you was speaking.
Oh, well. Welcome to 24/7 Flat Earth.
Actually, guys, do you want to take some fun and hear my song?
Not really.
Nah.
Okay, no problem. Continue your conversation, and I'm gonna join you if I like it.
Awesome. Just chuck yourself on mute there, mate, so you don't feedback, and yeah, sit back and enjoy the show.
Let's go.
Put yourself on mute, please.
Okay, let's.
Excellent, thank you. That was easy. But anyways, yeah, T-Dub, if you've got a whole heap of cameras sitting on top of your ball, each individual camera will get that slight arc effect when you rotate. And now we've got another one feeding back.
This earth are donut, like donut.
You're a donut. Please stop it. Well, anyways, back to our ball.
My internet's slow, so I'm going to come in and interrupt. I'm going to open my microphone and speak as soon as I have to do it. My internet's slow. Oh my god, bro. Like, is that the first thing you do when you walk into a room is just start talking? Or do you look around and see if anybody else is talking first?
No, we just drop right. Imagine doing that as a kid. My God, if I was and we were at friends' places and you run into a group of adults, started talking, you'd have got clipped fair up the ear.
Oh,
anyways,
man, your parent would have whooped your ass.
Yeah, I would have landed on me.
And see what happens.
Oh wow, that's crazy. So as you're looking out, see where and Swell Dog's posted it up exactly. You get that slight arc. So each individual camera will give you that slight arc, but connected together. If you were to rotate them, it'd just blend in smoothly. So no, we don't get the flower petal thing as you said, T-Dub, but each individual frame, and that's the problem. A lot of the Globers can't see or think more than one frame. We show them a photo. It's got a slight arc to it, and that's how our eyes actually work. So, yes, we do see one petal of the flower, but no, it's not curved. It's just a trick that our eyes do. So, I get what you're saying with the whole turning the ball underneath the camera, and when you go, if you were to take individual photos and then lay them out in their correct positions, you'd get like an exaggerated would be the McDonald's bump all the way around. It would look like a four-leaf clover, or how many photos you take to link them all together. we know damn well that's not what's happening because you actually got a yoga ball there. It's physical. You can see it. You can get the photos and do it, and then say, hey, look, here's the physical item. So we know it's an optical effect. We know, and anyone with half a brain in their head knows if they're on a sphere and they are looking straight ahead and then they turn 360 degrees, no component of that is going to dip down. It's a solid line the whole way. So if you're looking at a fixed distance, that should create a ring around where you are standing. So it's optical.
And what if
Yeah.
and what if I enter a room and interrupt the conversation because I just came into the room and I want to talk and I want to know what everybody's saying?
Well, depends on who you do it to. If it was Matrix Senior, you'd probably land on your bum.
I'm just teasing. I'm sorry to interrupt you guys.
You're right, mate. Why is it every time we're talking about cool shit, they always interrupt, but when we're just talking shit in general, no one comes in here and
It's like controlled opposition or something like that. You know what I mean?
it's like they know. They can sense it. But anyways, yeah, that's my take on it, T-Dub. So I think it's just optical.
So yeah, I mean, here you can see the last two pictures I posted, the horizon at the top of the frame, the horizon at the bottom of the frame. It's the same amount of convexity in both of those. And it's consistent throughout the whole video and all the panning. The only time it warps a little bit is if you have drastic like left to right movement of the camera.
So that camera does do a full 360 eventually?
Oh yeah, it's like it's going all over the place. It does everything that
Is there any times in the video where it actually does a 360 but does not bob up and down? And the reason I ask that is because what we can do, if it does a full 360 but doesn't bob up and down, we can just take screenshot, print them out, join them all together, and you'll see how it's got a wave pattern. Now, you know bloody well that if you're on a ball, you're not going to, and you stand there and you turn around, you're not going to get the wave pattern. But yet, the camera shows that. So we can use that and show people how linked together the picture doesn't line up. So that means it's an optical thing, it's a lens thing. So we can still use that to our advantage.
yeah, it's not perfectly staying still, but it is doing
Still bobs.
exactly what you said. I'm at 2 hours and 3 minutes. And it's bobbing a little bit, but it is slowly moving to the left, and yeah, and I think
So
if
it's
you took
swinging, yeah.
if you took screenshots, you know, and just linked them together, then you would see that yeah, it is like a bobbing effect.
Yeah.
I mean,
Because what I'd like
what's
to
the
do,
effect? Well, yeah,
it'd be nice to actually. It's probably easier if we do it on a T-Dub's yoga ball. Not that I'm questioning yoga, but anyways, T-Dub. And actually sit a camera on that, maybe a phone upside down, and put markers or something on there so you can show that it's turning. Photo, then print them out, and then join them all together so it shows the bubble effect. And then on a separate, film it. So you've got one person on a mobile phone filming it, showing exactly what you're doing, and then go, right, individually, this is what we see out in reality. But as a whole, this is what your individuals link up to. It makes a flower petal. Well, we know it's not a flower petal because the ball is right there. It's just to prove that it's an optic thing. That's all. Doesn't prove that it's flat or anything else, but it's just to show that it's an optical effect. And what's really striking is that same optical effect happens on a flat surface. It's like the bottom-up obstruction. And if you wanted to test it on a flat surface, go and draw a bloody great big circle on a basketball court or a netball court or some extremely large flat area you can find. Put your happy little camera in the middle and slowly take photos as you pan around 360, link them all together, and you'll get that same flower petal effect. Just not as extreme. Further out it goes, the more amplified it gets. Welcome, Best. Sounds like you have a question. Who is feeding back?
Akir.
That's Badania.
Dusty vagina.
Привет.
Jedi, were you listening to that conversation? Or did you just get here?
Mate, I've been here about a minute and a half. I haven't been here long.
Ah, okay.
Nice.
Well, just really quickly, this is what I was going over. An argument that flat earthers have made over the years have been that globe earthers cherry pick balloon footage that uses lenses that have distortion, like fisheye or wide-angle lenses, and they say, look, here's the Earth curvature. But flat earthers have sent up weather balloons themselves with a non-fisheye lens, and from that footage, we see a perfectly flat horizon. But
Yeah.
I don't think that footage exists, and I think that flat earthers have been cherry-picking footage that does use a wide-angle lens and using bits of the footage that don't pan up and down and show a perfectly flat horizon and then make little clips out of that and say here. But I've never seen anyone be able to link a source to someone that's done that. And then we've got flat earthers like Dwayne Kellum that do use infrared lenses and rectilinear lenses and send up weather balloons, and in that footage and in other footage that does actually use rectilinear lenses, the horizon doesn't look flat from that height. It looks like it's convex. From all angles of the frame, like 120,000 feet,
Wow.
and that there has to be some other explanation for why that happens. Maybe being that we see the same distance in all directions, or something to do with the way that the camera lens picks up light, or something like that. But there's a video in the side chat.
Okay.
Repost it, and yeah, this is a flat earther, Dwayne Kellum, and he shows footage in a bunch of different wavelengths, and you'll see that, if the horizon's at the bottom of the frame, you see just the same amount of convexity as when it's at the top of the frame. It's like 2-hour video. He's got tons and tons of videos of different launches, and then there's other footage, like when they sent up the world record amateur rocket, they used a rectilinear lens. The same thing happens. We don't see, when the lens pans around, we don't see the horizon turn concave ever, really, in the footage. So yeah, it's just a speculation, and maybe an FE argument that needs to be modified or something like that.
This puts me back into like the early days where we were getting. I still see this stuff from like. Has anyone heard of John Thor?
Yeah.
Yeah. So back in he's still doing stuff now, but with those types of videos, sometimes with like Eric DeBay, or sometimes with, like, as I said, John Thor, you'll see lots of things thrown like into the mix. High altitude balloon footage being one of them. I've seen loads of images of, hey, look at this really flat horizon without a GoPro camera and stuff, and hey, look what happens when we correct the GoPro camera for a real flat Earth by using computer technology. Yeah, I've always thought to myself about this. It's hard to say which one is which, so let's just get back down to the surface and measure it. But I'm going to look at this video, mate. I appreciate that. Give me a moment. I'll let you know what I find.
Yep. Awesome.
I've never heard of this guy, though. Who is he?
Dwayne Kellum, yeah, he's a flat earther. He does a whole bunch of balloon launches using different types of cameras and that kind of thing.
I don't know, dude. I've never sent the camera up into the sky.
Yeah. I mean, look, every single time I've seen someone send a rectilinear lens up into the sky, this is what we see. We see what looks like a convex horizon, and I speculate that the reason for that is that because you can see such a huge distance in all directions, we can see the same distance in all directions, and that it makes a circle of vision. So you're seeing a circle of vision. It's not curvature, but it
Yeah.
could be mistaken as curvature.
Yeah. Yeah, that's
Why
what
is
I'm
it?
saying. Go on.
Why is it, DJ, that everyone's got this idea that rectilinear lenses are some perfect solution to barrel distortion? They all bow down to it.
Yeah.
Well, they all have some barrel distortion, but the thing is, if the horizon's at the very bottom of the frame and the very top of the frame, we're not seeing it go from concave to convex.
It still swings.
That's yeah,
They all
but
do.
right, but not as it should.
It minimizes it. The whole purpose is to minimize it, but it still does it. So a lot of people seem to have this idea in their head, hey, it's a rectilinear lens, you now have no excuse. Well, it's like, no, it still does it, bro.
Yeah, rectilinear lenses are just wide-angle lenses pretending that they're a prime lens. And they've never been tested for distortion over great distances because that's not what they're used for. They're always used for short distances.
Okay,
I
guys,
remember
there is
India.
somebody here that thinks the Earth is flat.
Yeah. Hold on a
Okay,
second.
can you please?
Hold on a second. Hold your quick. Because I was going to bring this up before, because I've heard Indio talks about how the lenses that they're using for all of these launches aren't built for this type of crazy pressure that they're being put under. And it could be something to do with the calibration of the lens, and the pressure that they're going up into could have some type of effect. So he put an article, I think it is, or a paper in the side chat there.
Yeah, they don't
So
really
basically,
make consumer lenses for going to high altitudes, as there's really no need for that.
all right. So this means that when the materials are put into low pressure environment, their relative refractive indices increase. Since this absolute indice is constant and low pressure means low pressure refractive indices of air, this cause increases the refractive power of the system, therefore also causes defocus.
I always said, and I maintain, that it is totally possible that if you go high up enough, it might look curved just because of how our vision works.
Right. I mean, it makes sense. I remember going to the beach, and I was up on a big headland, and it had a huge distance of the horizon I could see. When I would look straight out ahead of me, it looks perfectly horizontal and flat. But then when I would pan my head all the way across the horizon, it looks like a big giant circle. And I would have noticed anything, but I had been looking into flat Earth for a while, and I was like, damn, it looks like the curvature of Earth. And then when I took a bit more of a closer look at it, shit, it looks like a big flat circle that I can see, that I'm looking out at. Yeah, it's definitely
Right.
seems
So, I
to
mean,
be.
can you imagine those people back in the 60s, first time they go up pretty high up, right? And they take a couple of pictures and they're like, what exactly are we looking at here? If I was to be generous to these people, there is a real possibility that they are actually not lying. They fully 100% believe they're seeing Earth curvature.
Right. But I think it could still be something more to do with the camera sensor, or something to do with the lens, kind of like what India is talking about, because I don't know, it's just that
Here's another
bubbling
idea. It's just something to think about. You
Other
know how some people
theories.
are long-sighted and short-sighted? Is there any noted uptake of one particular side saying, hey, we see this more than the other side? So long-sighted versus short-sighted is one crew saying that they see the curvature more often than others, or the other side, being that these are different abnormalities of our eyes. Just throwing it in there, mate. Just another spanner in the works, that's all. But anyways, our friend is busting at the seams to get this question out. I think we should let him.
What if that
Yeah.
there is like the Earth is like a circle, it's around, but in the exterior there are more continents, like the Antarctica wall, I think. It's like a theory. What do you think about this?
I think it's a fun speculation, but it's something that we don't really have any evidence for.
Okay, okay.
But it is an interesting speculation, sure.
Yeah, I heard about the Antarctica wall and it blew my mind. And I heard you guys talking about the flat Earth, and this could be like another theory, speculation.
Yeah, yeah. Yeah, I don't know. Like, I think that if you have a large body of water, then it needs to have a container.
Yeah.
You know, like a lake. A lake always has a shoreline. A sea always has a shoreline, and if the world oceans are like a big pond, like a big lake, then it would be very logical that there would be more land of some kind. How far away is it? What is it like? I have no idea. Or it could work a different way that I haven't,
Yeah,
that
you
I
have
have
no
no
idea.
idea about. So I think it's not a crazy idea to say that there could be more land, because there's more land on the outside of every other body of water we can check.
That's right. That's right. Just imagine, bro. That would be crazy.
And if it's far away from where the sun takes its path, then it wouldn't be a crazy claim to say that it could be frozen there as well. So,
Yeah.
not saying that's all
And a
factually
lot of
correct or anything, but
yeah, that's good. And all of the speculations about the extraterrestrials that they're saying, the extraterrestrials are like humans that are across the Antarctic border, under Antarctic wall, and that's what they're saying about extraterrestrials, that are people on Earth above that wall. I mean, that that's a crazy speculation, but it could be. It could be.
it is Sunday, by the way. It's speculation Sunday. We do cover topics like I'm watching it from a lower altitude now, so from 22,000 feet, it doesn't look like there's any convexity. 30,000 feet, it does look like there is. Post screenshot. All right, this is what the horizon looks like at 21,000 feet.
What? Why are you guys turning silence and
Well,
Because we're having a conversation, and typically people want to listen to each other when they have conversations. So while one person's speaking, the rest of us mute ourselves so that we can fully understand what's being said to us.
but no one is speaking? I cannot hear anyone speaking.
You literally jumped in at the end of somebody finishing their sentence. So allow the person to
Oh,
carry on.
okay. I'm gonna mute.
Thank you.
Yeah, not sure if you can hear me talking, but yeah, I was talking. We're kind of analyzing a video at the moment of a high altitude balloon that has an infrared camera, kind of rectilinear.
Almost كامل بقى.
Hmm?
Hello guys.
Hello?
Everything is okay?
Yeah, everything's good, man. Thanks for asking.
So you have a topic here or what?
No, you're more than welcome to bring up a topic about the topic topic of the channel, Flat Earth. Do you have any questions?
So I don't think.
Andy.
I don't think. Hangs up.
See, no one's talking. They don't want to drop in. DJ starts dropping facts again, and these clowns will drop in. Keep talking, DJ. We can get some more entertainment.
Yeah, I'm taking screenshots from different altitudes. I'm up to 42,000 feet at the moment, and so yeah, Neil deGrasse Tyson says you shouldn't be able to see the curvature even from 300,000 feet, which was the height of the Virgin Galactic. But then all of the other sources, pretty much, I mean, the mainstream sources say from about 36,000 feet or something, you can start to notice the curve. 50,000 feet.
So on that particular camera that's being used for, I don't know what it is, the sensor on it, is it a sensor that picks up better in the center, or is it a... See, there's so many things that we can sort of point the finger at, or better still, try to eliminate.
Yeah, I think he shows a bunch of information about the lenses at the start of the video.
I am liking the IR stuff. It's pretty tidy. But one thing I have noticed, and you've probably seen the same thing, where you get that effect where it sort of looks like it's an egg, where you'll get, there's a bit of a point in the middle and then it sort of tapers off at each side. That's the effect I'm talking about with our eyes and lenses also. You don't see it all the time. There's only some of the shots that do it. Like, you know, that Earth picture where we say to people, finish the arc off? That effect. Or to complete the circle.
Shows the distortion of some of the lenses here. So this one's got, according to the factory specs, 1.5%.
So what's that in comparison from center to sides, total across all images? It's sort of very vague, some of their specs and that, aren't they? So that's on an 8 megapixel camera. So what was it, a GoPro?
Yeah, I think here's a picture. Yeah, they're all, most of them are attached to GoPros, but they're not all GoPros.
All right, yep. Because the other thing with GoPros is when they say rectilinear lenses, some of them, the new ones, actually unscrew the lens and you screw in a new lens. The older ones actually clipped on lenses. So you still had your wide angle underneath with a rectilinear over the top of it.
Right. Yeah, here's a picture of the front lens.
Oh, yeah, cool.
How high are you so far? I've got up to 73,000 feet. I skipped the beginning bit.
I'll play the audio from the start of the video, so he explains a bunch of stuff.
High altitude balloon 15. Welcome back, everyone. I'm back with another video. Now, this video has taken me longer to prepare than I anticipated due to some family obligations, my job, a computer that simply does not like the program I use to prepare the video for upload. I overcame the computer issues recently, and now that I'm over that hump, the next video, High Altitude Balloon 16, won't take as long as this one. One of the issues I was having was with Dashware. It's the program I use to overlay data onto the screen. It just would not work with the new codecs my video editing software used, and I had to do some trial and error, and I got a pretty good workaround on this issue, and I can even now overlay data onto 4K videos. This will come handy next year. I will be purchasing new camera equipment that will be able to record starlight into the stratosphere. It will also be able to record with various filters. This launch was the first launch we used with hydrogen as a lift gas. The balloon type we used usually burst at around 109,000 feet when we use helium, but with hydrogen it reached an altitude of 115,220 feet. That was about a 6,000 foot increase. The main experiment on this launch was to record in the infrared spectrum. The balloon also carried another camera without any filters for comparison purposes. There was a large fire in the area the balloon flew over, and the ground was covered in thick smoke. I'm not sure if the infrared filter could see through the smoke as well as the water vapor in the atmosphere. So I will be doing another launch this winter when the fires are out and compare that footage with what we got this time. Let's see. When the balloon traveled over large bodies of water, they recorded black, just like the test video I showed in the water above. I find this very interesting, and while I was getting this video ready for upload, I was viewing some deep ocean documentaries, and when the submarines dive into the ocean, the water gets darker the deeper they get. And I studied those documentaries, and I watched closely how the lights from the submarines reacted with the dark waters. Then I compared that to the footage I got from the balloons from the sunlight and how it reacted above the troposphere. And they seem to be quite similar in nature. I just found that very interesting. I'm going to be doing a little bit more research on that. Okay, there was some other equipment on board along with the cameras. There was a data recorder and 3 tracking devices. Several people have asked, why do my balloon videos have curve on the horizon and other balloon videos on YouTube don't? I've decided to answer this question on this update. There are a lot of high altitude videos on YouTube that were shot with a wide angle lens. The wide angle lenses produce a distorted view of the objects recorded by the camera. This type of distortion is commonly known as barrel distortion. Some people use editing software to remove this distortion. When the video is corrected with editing software, it's often brought to 0 distortion. But I don't know of any board camera that can take a picture or a video with 0 distortion. Wide angle lenses distort the image more than rectilinear lenses, and most people think that rectilinear lenses have 0 distortion, but this is not true. Some people say that the lenses I use on my cameras are rectilinear, but I question that. I would say that they are low distortion lenses. But for the sake of argument, I'll call them rectilinear. The lenses I use have a distortion rate between 1 and 2%, above and below 0, with 0 being no distortion. 1 to 2% is a small amount of distortion, and it's hardly noticeable when the object recorded by the camera is relatively close. I would say about maybe 5 miles or so. But these lenses don't do so well on cameras recording large objects that are a long distance from it. Before I continue, I need to tell you a little more about the cameras I use. The cameras I use are small and lightweight. This is what makes them a good choice for recording video on a weather balloon. The cameras record a video digitally by focusing light on the image sensor. Because the cameras are so small, their lenses and image sensors are also smaller than what would be on a professional DSLR camera. When manufactured, these cameras came with wide-angle lenses. After purchasing the cameras, I removed the wide-angle lenses and installed low distortion, or for sake of argument, rectilinear lenses on them. I did this so that the camera would record an image that would be close to what we see with our own eyes. As I stated earlier, there is no lens made that has zero distortion. The lenses I use in my cameras are M12 board lenses that have a focal length of 4.35mm, 5.4mm, and 7.2mm. As I stated earlier, these lenses don't match perfectly what we see with our eyes, but they do come close. One has a wider field of view, another has a narrower field of view, and the other one, it comes really close to what we see. The lens I chose for this flight has a field of view that is wider than what we see. It has a focal length of 4.35mm. This means if you take a picture using this lens, the image will show more of the area than what we can see without moving our eyes. The objects in the image would also appear to be smaller and pushed back. Now that I've given you some details of the equipment I'm using and how it works, I can tell you why you see the curve on the horizon. Earlier I stated that my lenses do a good job on a camera that is recording objects that are close to it, but a not so good job on objects that are large and far from the camera. I will assume that everyone can agree that the horizon is a large object. The horizon can be recorded up close, and the horizon can be recorded at a distance. Imagine you are on the beach looking out over the water, and you take a picture of the horizon. You're using a GoPro Hero 4 with a 4.35mm lens, just like mine. Let's say the elevation where you took the picture was 9 feet above sea level. That would put the horizon about 4 miles from the camera. That would be relatively close to the camera. Now imagine putting that camera on a weather balloon and send it up to 100,000 feet above sea level and take another picture of the horizon. The picture you just took was a horizon that is now 426 miles from the camera. The horizon is also a lot wider than it was when you took the picture at 9 feet above sea level. Remember how the camera works? The lens focuses light on the image sensor. This is when the 1 to 2% distortion will come into play. The object is now so large and far away, the distortion caused by the lens is easier to see. That distortion was always in the lens. It's harder to see when the object recorded is small and close to the camera. It is easier to see the 1 to 2% distortion on a much larger and further back horizon. The bending distortion, also known as barrel distortion, is present in all lenses, even rectilinear lenses. The difference is you would have to have a much wider and longer shot to see the distortion with a rectilinear lens. I hope this clears up the matter for all the folks who had questions about it. I will now show you what the balloon cameras recorded on this flight. Y'all take care. Bye. Oh yeah, the illustrations that I used in this presentation was done by my daughter. She has a YouTube channel too. It's called Soul Jumper. If y'all like what she did here, y'all can check out her channel as well. Okay, y'all. This is the first hydrogen launch. You ready? Here we go.
So that's pretty cool. He actually takes the lens out of the GoPro and screws in an infrared rectilinear lens. I wonder how much that costs. The little
Kalari
lens.
actually convert GoPros over. It's not just a case of changing the lens. You've actually got to get the filter taken off of the sensor in the first place, because there's only one video camera years ago that actually came without the IR cut filter. And that, remember the one that AI was talking about that could see through clothes? Because it basically had night vision mode all the time. It was because of it never came with a IR cut or IR filter, I should say, to block out infrared light. So they get the GoPro, rip it apart, peel the filter that's on the sensor clean off of it, clean it. If you want to have it open so you can put your own specific filter back on, you can. Or if you want a very specific wavelength put back on, you can. And that's what the place that I'm buying my camera from, that's what they actually do. So you get a choice. You can go full open and you choose what lenses you want to screw in or filters you want to drop in. Some of them have got little drop-in ones that you actually put inside the camera, and other ones you just screw on the lens. I'm going for the lens screw-on ones. But yeah, you can actually send GoPros to them and they'll do it for you.
Huh.
So there you go, one that's already been converted. 500 US. GoPro 7. Full spectrum. GoPro 13, 1100, full spectrum. That means you can put your own lens on, pick what wavelength you want to cut. Pretty cool stuff.
Yeah, for sure, because it's light enough. You could strap it, you could put it on a drone and do high altitude long distance observations.
There you go. If you want it converted, $400 action camera conversion. So that's your GoPros and all that kind of class. That's US. Normally takes them about 4 to 5 weeks to do it. So let's just pick the latest one, which is the Hero 13 conversion type, full spectrum, and yeah, $400. There you go.
Pure water. What makes you think that we haven't grown up with that sort of imagery? I was exposed to that sort of imagery before you were even in nappies, before you were a gleam in your daddy's eye. I was looking at imagery like that. What makes you think if I saw it then and I'm not convinced that I'll be convinced now? Not that I wasn't convinced. I used to be convinced it was true because I didn't question it. I just looked at it and went, oh, wow, they said it's real, so it must be, which is really bad logic
No,
and a
I'm
really
not
bad standard of evidence.
No, I'm not saying that. I mean, I just added a look at the footages after I said, take a look at the formulas and everything, like physics, maths.
The formulas and the math have been debunked through observation and measurement. I told you that.
No, it didn't,
Yes, they
man. I
have.
mean,
Yes,
you
we've
guys
made
are just
observations and measurements which contradict the globe claim geometry. So the surface drop over distance, which should exist if the Earth is a sphere with the claimed radius value, using your math, right?
Yeah.
If it existed, we would detect it, we would measure it, we would observe it, and we don't. It's not
I mean,
there. We look straight across large
you
bodies of
measured
water all the way to the other side, shoreline to shoreline, 20 miles, right? We shoot lasers across that far, and they hit their target. They're seen by a camera, or they're seen by a human eyeball. Okay,
Yeah.
if the curvature was there, you wouldn't see it. The light would deviate away from the surface.
Yeah, and that's exactly what's happening, dude. I mean, even flat earthers has failed. I can send you the video here after the experiment. There's like a lot of footage of flat earthers failing that experiment, and also,
No, there isn't. There isn't. There isn't a lot
there
of
is.
footage of flat earthers failing that. No, there is not. I
Dude, I
bet
can
you're
send
referring
you
to one
one
instance that you saw on Netflix. One. That's not lots. That's one.
No, I can't send you more than that. I know.
You can send me more than that.
Excellent.
Okay, show me
Post it.
more.
And also,
Post
I can show you the videos that proves the Earth is not flat. I mean, you know, at some point, I just feel like it's unnecessary.
Okay, go ahead and show us.
Yeah, for sure. The problem is you guys are so ready to reject and so ready to
We're ready for you to post your data so we can scrutinize it as opposed to scrutinizing you.
Yeah, for
Yeah.
sure. I mean,
The only thing you had was a Netflix
I'm just thinking of, like,
documentary.
what type of data should I send you, because there's a lot.
Anything that backs up your claims.
Even looking at the aurora, like the northern lights, it wouldn't be occurred if Earth was flat because of the magnetic field.
Why not?
No, measurements of the Earth's curvature, not looking at the sky and then affirming the consequence that something should be happening.
What do you mean?
Like,
How the northern
I
lights
posted
gonna?
information and I tagged you directly in it earlier, right? That was an observation, and then the formulas that went along with the observation. Either concluding that the Earth already has a known radius value, 3,959 miles, the distance to the horizon that should be according to the observation, and then identifying the radius value if you don't know the value already, radius value for that observation being 21,296 miles.
Dude, have you ever seen a ship disappearing from the horizon?
Yeah, that's exactly what my example was. I'll post it again for you so everybody's caught up.
No, I mean, it's not against what you said. It's actually a basic proof of Earth is not being flat, because if it
No,
was
it's not.
disappearing,
It's an assumption.
Allow me. I'm agreeing with you. Okay. In
Yeah.
this instance, the observer is standing on a ball. Okay. And then the boat off in the distance, disappearing bottom up, sitting on that ball. The horizon beyond it, behind the boat. Okay.
Yeah.
You can see the boat. So that means the boat's not beyond the horizon yet. Right? Because if the
Yeah,
boat was disappearing, it would be beyond the horizon. But the horizon's beyond it because you can still see it.
No, but during the
So that
time,
means the boat, 10.6 miles away from a 15-foot observation height above the water, I'll just assume that 0.4 is the remainder to the horizon, right? So 11 miles, right?
look, I don't
So
know the numbers. I don't know the numbers.
I posted the numbers. It's right there, 58 minutes after the hour, right? This is an observation done by our good gentleman Indio, right? He
Yeah.
went to the beach. He found a good day, took his camera. It could see IR. He's looking off in the distance, found a boat. He even did it was either him or DJ, went out of their way to identify the boat and its distance and its location, gave you screenshots from Google to identify its specific location so that we could verify that our values are correct. 15 feet above the water, objects 10.6 miles away from the observation point, right? Now,
Look. I mean, how come during the while it's disappearing, the bottom of it goes under first, like beyond the
Angular
horizon.
resolution.
Yes.
No,
So
no,
what
no,
we're trying
no.
to
It's
do
not
right
because
now is
of that.
identify size of the sphere, right?
It's
Because we're
because
using the observation to give us the radius value to confirm that we're standing on a sphere, right? Step one.
Wait, how come? Or let's take a ship one more time, okay? But this time I'm not going to talk about the horizon. There
No,
are
I'm going to talk
colors
about the
that you
horizon
can
because
literally do
that's how I
24.
know that I'm looking at an object going down and around the ball away from me and the earth is getting in the way. That's how I know. So I'm going to talk about the horizon.
Without the curvature, how is that possible? Like the scene that you see at the bottom of it disappears first. How come?
Angular resolution. You seem to believe, my good friend, that it's the curvature cause and effect relationship. It's actually an optical thing. It's to do with your eyes and the ability of how far a particular lens size can see. Its ability to resolve a particular thing.
Dude,
Now,
alright,
you promised us, before you get all excited, I would just like to re-inform you of something that you promised us. Flat Earth measurement failures. Can you at least post one in the side chat for us?
Yeah, but before that I just wanted
Yeah, there's
to
no but. I would just like to see the data so I can look at that whilst you're talking. That would be awesome, mate.
Alright, yeah, let me just check that for you. Flat Earthers fails.
Are you Googling that? You came in and
Yeah.
made the claim, so that would normally indicate that you have prior knowledge of it. So you don't have any knowledge of any flat Earth
Yeah,
failures.
let me just send you a compilation video of it, okay? So you can just check all the failures of it. I mean, why you're talking to me condescending, I don't understand it. I'm just
Specifically of the laser
arguing.
test measurements, because
I'm
that's when you said that I detailed how people shine lasers over large bodies of water and they hit their targets, and you said, yeah, but there's lots of cases where that's failed and that you can show it.
Yeah, I mean, I just sent you a compilation video that I just found. I mean, I can send you even more. Like, you can just watch it for half an hour. There are like a bunch of footages in here. You guys can check. I don't think it's important, by the way.
Well, it actually is important, and the reason it's important is because you have absolutely no idea what that video is about. That first one. We were talking about laser tests, and now you're showing us a test that was done with a flashlight. That's not
Okay.
the same.
Yeah,
What are you
let me
laughing
send you
for?
that one too.
Because that's what happened.
Dude, I'm laughing at the way you're arguing to me.
You're
I
laughing at because you know I've just nailed your sorry ass to the floor.
No, dude. I mean,
Yes, dude.
Dude, wait.
How about you
I've been
address the
arguing.
specific arguments?
I've been
The
arguing.
discussion was about lasers, and you're trying to flip it over to torches or flashlights.
Dude, I've sent you the laser video as well. Okay, just go and check it, but don't talk to me like
No,
that.
you said there's
I don't
lots
understand.
of examples of
I've
that,
been
of
arguing.
laser tests.
I've been arguing
Pure
here.
water,
Dude,
stop. Be honest, be honest. Are you
yeah.
aware of multiple instances of laser tests failing to prove the Earth is flat or to indicate that there's no curve? Yes or no?
Wait,
It's a simple.
are you talking about the experiment being correctly?
Are you aware of many instances, what you call experiments, where a laser was used across a large body of water and it failed to measure flatness?
Yeah, dude. I mean, I've seen footages
Name
of
it.
Okay. Show more than one, because you haven't showed any, actually. Not one. You have not showed one.
The last one was
Nope,
laser.
there's no laser.
That's not a
I didn't see a
laser.
laser. No lasers.
Here, wait, let me see.
Torchlight. Like I told you, that's the problem. We're talking
think
about
you
lasers.
made it up.
You're showing us other things.
You made it up. Just admit you made it up. You don't know of any. You probably don't even know of any laser tests at all.
All right, maybe I cannot find the video right now. I remember that I seen that. I mean, guys, we've been talking about like the curvature in terms of physics. And now you guys are talking about
Yeah, that's what we're
the
talking
Well, it's
about. Is
need.
that's how we measure it.
lasers, light traveling across the surface of the
I
water
don't
above
have
it.
I don't have an archive that I like, document these videos. I'm trying to find.
We do. We've got
I-
multiple, many.
Yeah, because it's like, I mean, you own this channel. You're basically doing that and having this conversation all the time. You might be ready for this. I'm not. I'm not documenting.
Well, how
videos.
about if you're not ready to back up any claims that you may or may not make in the future? Here's a great idea. Have your data to back up your information. So if you're going to come in and tell us how you like the flavor of purple crayons, and that's what it sounds like you like, at least have some kind of documentation that says purple crayons are grape flavored and that we should all enjoy them.
Look, Metatrix, bro. I've been talking about like Horizon or like ship disappearing.
Yet we understand what you were talking about.
Yeah.
Listen
so,
carefully. Prior to that, you made the offer to back up your claim with data. I pulled you up from talking about bullshit Horizon stuff because you were wasting our time.
Earth is flat, man.
I don't argue.
Shut up.
Argue with you like that, and you're just being.
Not you, Pure Water, the other one.
Yeah,
So
but still, Metatrix, like I don't like the way that you argue. We've been talking like
The problem is you're not arguing. You're making excuses.
No.
Do you have the data or not? Yes or no?
Dude, I just told you that I don't document.
Do you have it? Yes or no? Be honest. Don't be making excuses.
Look, if you interrupt me one more time, I'm just.
Yeah, do you have the data? Yes or no?
I will give you the answer. Just give me a second.
Excellent. I just want the answer. I don't want the meta. I just want a yes or no. Do you have the data to back up? Okay, run away. So you're a coward. We knew it. Right, Spitter, you're up.
Hey, hello. You want to say?
Hi. How are you?
What, So,
Yeah.
Yep.
Hello there.
Posted a video in the side chat from Dearth, deep inside the rabbit hole. It's regarding the Artemis 2 mission. Have a look at it. It's very short. It's just a quick short from YouTube. I'm asking if it looks like a balloon to you. It's not a long video.
Dude, I just cannot believe that I don't have the permission to write on this channel anymore.
Why are you sooking?
It's just
maybe
so
if you
dumb.
weren't being such a sook. Mate,
Pure
pure water. Pure water. Stop crying. Hey, guy. Hey! Stop crying. We don't listen to sooks in here. Okay, how about we just solve the problem? Shut up, Junior. We're not interested in you crying. We're interested in your data. You haven't provided any. You've made all and every excuse why you cannot, have not, and will not. We're not interested in the bullshit. We're interested in the data that backs up your claims. You have no data, so therefore you have no claim. So you can apologise for wasting our time, or you can sit there in silence. I don't care. But crying about crying is not going to help your cause.
Darvo also will not get you your text permissions back, for the record.
So pure water. I can tell that you haven't looked into this, because if you watch that video that you posted, okay, the fourth example they give is from a National Geographic documentary, where some researchers and independent researchers, aka flat earthers, went out to do some tests. Now, one of the tests involved making a flag with several horizontal stripes on it of different varying colors, red and white, I think. Maybe a black one was thrown in there. And they sent it out on a boat, right? And they had a telescope at 8 inches on the shoreline, at 8 inches above the surface of the water. They were hoping that after a certain distance of that flag traveling out on a boat,
I'm so sorry.
it
Which
would
video
begin
was
to
it?
become, listen, it would begin to become obstructed from view, so that you may not be able to see a portion of the bottom stripe or all of it, right? Now, they got it a little beyond a mile, and they suddenly couldn't see some of the bottom of the stripe, right? The bottom stripe on the flag. They put it down to Earth curvature. That would be where the horizon begins, so that no more of the water surface could be seen beyond that point, right? And everything above the surface of the water beyond that point would look like it's below the horizon, and dipping down more and more the further away it is. But what we see when they say that there's there's curvature there because they can't see the bottom stripe, we actually see water surface beyond that point, indicating that it's not the curvature of the Earth, because there wouldn't be any more water to be seen beyond that point. They failed, right? They failed to even recognize their mistake, right? So whatever's happening there, waves, distortion of light, right? The optics, all that, the weather conditions, that's the reason. There's other reasons for why you can't see the bottom of that stripe, and not because of the curvature of the Earth, because it hasn't even reached the curvature of the Earth if the horizon is beyond that point. Right? That has to be the horizon line.
But even
in the model, right? So even they failed, and you wouldn't recognize that if you'd have watched it and evaluated it critically, properly.
Yeah, I'm just looking at the footage right now.
You can see the screenshots that Matrix put in the side chat. We can clearly see the water continues going beyond the flag. We can see it way off in the background. So you shouldn't be able to see any more water past the horizon. It's a globe.
That's a debunk of the globe geometry right there.
I'm just thinking of if we like extend the distance, how would it look?
Yeah, great idea. So we've got tons of really long distance observations that have been done really, really well. And
I mean, in the long
we
distance,
can see things. We can see things that should be hidden completely behind the curvature of the Earth by like a 5-story building, 50 foot, 60 foot, or even more, depending on the observation.
Yeah.
Really nice quality observation as well.
Yeah, so for example, take a cruise ship, like a big one,
Yep.
and take a look at it's disappearing from the horizon. So the bottom of it and like the whole ship disappears at some point, right? And it starts from the bottom of it and it goes to the up front. So
Well, that
during
actually doesn't happen most of the time. And I actually grew up on the east coast of Australia, right next to a cruise ship hub, where the cruise ships leave to take off into the ocean. And
But
what
how come
happens?
it happen?
Well, what
I mean,
happens most of the time? What happens most of the time is the cruise ship gets smaller and smaller and smaller. Now, the human eye has an angular resolution limitation, so once something gets below 0.02 degrees, you can't see it anymore. So most times you'll see the cruise ship going out, and it will be getting smaller due to perspective. Once it gets below 0.02 degrees in your field of view, you just can't see it anymore. It looks like it's gone. You can still see the horizon, but it looks like the boat's gone beyond the horizon. Now, we have amazing cameras now, and we can zoom in, and we can bring that entire boat back to view again. Most of the time. Sometimes we have ocean swells, like waves. Huh?
do you have a footage of that? Like when you zoom in, you
Yeah,
cannot
yeah,
see
yeah,
your eyes,
yeah,
but after you zoom it,
yeah. Just give me 1 second. I'll just find it. I was just looking for it actually before I open my phone.
yeah,
All right, go. Actually have a whole bunch of them. Post one of a really giant boat first.
yeah, giant one would be better.
Yeah.
And also the roots, guys. I want to talk about that too because, like, I mean, if you keep going at the same direction, and eventually you're gonna
One at a
come back to the
time.
place that you started.
One at a
Yeah, we
time.
can we can
You
we
can't
can get
even get
onto
past.
yeah, we can
You
get
can't
onto
even get
other.
past the horizon.
Yeah, sure. Okay,
All
let's
right,
go to.
check out. Here's one example. All right, so we can reverse engineer this image. Okay, when he's zoomed out, we
Yeah.
can't see the boat at all. We have a nice calm day without waves. And imagine if he didn't have the zoom camera.
Yeah, so he wouldn't be able
And
to see, you say.
yeah, he wouldn't be able to see it. And let's pretend that the boat was right next to him where he's standing, and then he's going to watch that boat sail out to where we can see it when he zooms in. He would watch the boat go out, out, out. It would get smaller until it gets below a certain size, and then he won't be able to see it anymore. Then he could pull his camera out and say,
Yeah.
"Oh wow, the boat looked like it was gone, but actually the whole boat is still there. It was just an optical effect that was making it look like it disappeared."
Yeah.
So I can,
So
yeah, go ahead.
I mean, at some point, there's like two questions because I feel like from this distance, the ship should be disappear, like at least a little bit. So I get your
Yeah.
point.
So
Uh,
the horizon should be 3 miles if you're standing at the beach or any body of water, and you're say 6 foot tall. The horizon should be at 3 miles away. So once the ship starts to go past 3 miles, the bottom should start to disappear. By the time it gets to say 10 miles, the bottom 50, 60 foot should be missing behind the horizon. Probably most of the boat. But we can track these boats, okay? And we can see the boats huge distances out into the ocean.
yeah.
Like 10, 15 miles away, we can still see the whole boat.
So after seeing this footage, there's like two questions comes to my mind. The first thing is the route that I've been talking about, and the second is, where the ship is going. I mean, is it endless? Like, if the Earth is flat, there should be an edge, right? This should be a classic for you guys to bring that
Well,
up.
okay, yeah.
So
So
which one?
we don't claim that
You
the
want
Earth
to talk?
is we don't claim the Earth is a flat planet. So most people think about the model of the universe that we all get taught while we're growing up, and that we're on on a ball that's floating around in space, essentially. And then they hear about flat Earth and they try to change that to like a flat planet. That's not the right way to think about it. We don't claim that the Earth is a flat disk floating around in space.
What do I need to how do I visualize it?
Visualize it kind of like the foundation of the system that we live in, like the floor, basically.
Yeah, yeah.
And that, I mean, the way I like to think of it is that the 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 oceans of the world are kind of like a large lake, and then the continents, you could imagine them kind of like islands inside the right on a huge scale. I would
Okay.
argue that to have a large body of water, like a lake, for example, it's
Yeah.
where you have a container, right? It's the low spot in the land, and then the water gathers, conforms to the shape of the container, and then the surface of the lake is flat, like a big scale
Yeah.
version of that. And then we have the celestial bodies up above us in the sky, like a big clock, right? Everything moves in cycles and resets.
How about like the edges then? I mean, there should be an edge, and ships are going that way. Well, for example, there should be a route that goes to the edge, right? If I just keep going,
Well,
why
I
can't
mean,
we
when
do
you
it?
say edge, do you mean kind of like the edge of a lake?
Yeah, like in terms of like if the Earth is flat, there should be an edge, right? So what is like what's there?
Yeah, I'm not sure. There's actually something called the Antarctic Treaty. I don't know if you've heard of the Antarctic Treaty before, but it prevents any free exploration past 60 degrees south. So there's basically a line 60 degrees south latitude, and you're not allowed to freely cross that line unless you have a very strict permit that you apply for through the Antarctic Treaty. So it is a fact that nobody has ever just kept going south or kept going away from the north. And then what would happen if they did that and the Earth was a globe is that they would come back around. Right? They would circumnavigate around the globe and they would come back to where they started,
Yeah,
and that would
yeah.
debunk a flat Earth. But no one's ever done that circumnavigation north to south. No one's ever just kept going south, right? Point the compass south and fly in a plane or go in a ship and keep going south. It's not something
Yeah.
that anyone that we can validate has ever done. But what's interesting is that a huge amount of people have done circumnavigations, but only east to west. And east to west is very different than north to south, right? East to west is something you could do on a flat Earth or you could do it on a globe Earth, because east
Yeah.
and west are circles around a North Pole.
Yeah, but I mean, sometimes they determine the routes because of the curvature of the Earth. So, for example, in planes, they're not going straight forward to the places if you're getting over the what's the thing like in the middle of it? I forgot. There's a
Equator?
lot of what?
Equator, is that what you meant?
Oh yeah, equator. So because of the curvature, it's like a little bit bigger in the middle, right? So they're just taking the roots from that, and they're like given a little curve in the plane flights.
Well, what you're seeing when you're seeing that curvature on the map in the plane flights is actually just the path of the plane plotted out on a certain type of map, which is called a Mercator projection map. It's the big rectangular map that most people are used to seeing, and it has a lot of distortion. So when you plot out the path of the plane on that particular map, it's going to look like it's taking an arc. But if you plot that out on a different type of map projection, it doesn't do that. If you have a look in the side chat, the top one is kind of like the map that you're going to see on the back of the plane seat. It's a Mercator map. It's going to look like the plane is taking that arced path.
Yeah.
But the bottom one, that's the exact same flight, the exact same path, but that one's mapped out on an AE map, different type of projection. And then all of a sudden that looks like it's taking a straight path. So it depends on what map projection that you plot it out on.
Oh, okay. And like even from the flights that actually, I mean, I like looking outside during the flights. You can see the curvature at some point. So it's observable, I'd say. I mean, I didn't do any science of it, like in terms of putting it into a formula or something. But from my observations, you can just see it.
Yeah, I mean, I don't know. I've taken flights, a lot of long distance flights at high altitude.
Yeah.
And I'm always amazed how flat it looks. Personally, I've never seen any curvature.
Really? I mean,
I know there's certain types of planes that have certain types of windows, and if you have a look
Yeah.
at the design of the windows, they have very thick rounded glass, triple layered thick round glass. So I know
Yeah.
some planes can make it look like there's curvature because of the type of windows. Maybe I haven't been in one of those planes, but we have footage where you can see through the window and it even looks like there's curvature on the runway when the plane's at ground level. So I know that there are some planes that do have that, but yeah, I'll put a time lapse in the side chat here. This is a time lapse of a long flight, but it's condensed into a 60-second time lapse. And yeah, I don't see any curvature at all there. And in fact, you shouldn't see the curvature of the Earth from that height, even if it was a globe, because it's only
And you're saying like right on the edge of it, that looks just like the horizons because of the resolution, you say?
well, it just looks flat. I mean, you're always going to get a little bit of barrel distortion. So right on the edges of the image, it's going to look like it curves a little bit. It's just like a byproduct of the lens. But I don't see any curvature in that. It just looks flat. And from that height, you would only see 0.1% of the surface of the Earth. So mathematically, it's not high enough to see the curvature of the Earth. But I can understand why some people might think that they're seeing it. Maybe it's the window. Maybe it's something like the
How
lemon
about
illusion. You could look up that. It's when people think they're seeing curvature, even though there's not actually any curvature there. Because and that could be because of your sometimes I look at a horizon and I think, wow, I can sort of see the curvature in that, and then I'll draw a line across it to check, and it's perfectly straight. And then there's also the argument that you can see the same distance in all directions. So it can kind of look like a flat circle because we see in a circle, right? Like if we went out into the ocean on a canoe and you looked
Yeah.
around 360 degrees, you would see the horizon at the same distance every degree, and that would make a big circle of vision around you. So you could mistake that as curvature as well.
I mean, even in the footage that you sent, so in the horizon, I mean, I still think if we cannot see beyond that, is it because of the resolution or that's the like edge of world in flat Earth visualization? And also, I mean, it comes to the same point. Why don't we take footages that has been taken from space? It's
Well,
actually
the
like
the problem is we can't go to space to check. I mean, we could. You'd have to take that on good faith.
yeah, but there are like bunch of people who is seeing that the spacecraft going up to the space, or like you can see like live
Well,
image
you can
of
see a rocket.
goes
Like
up.
we can all agree that rockets go up into the air, but that's
Yeah.
not necessarily
Oh, and
seeing
also
something.
even in the like the little records that you could prepare by yourself, not by yourself maybe, but there's some high quality records that are small, and if you put a GoPro on it, send it to the upper direction, you might see the picture in
Alright,
there.
I'll be there in 5 seconds.
I mean, maybe we cannot like create a whole spacecraft and take the same footage of SpaceX sends us, or like NASA sends us, or China spacecraft send us. Maybe we cannot take that, but we can get a little bit of curvature from that little rocketries as well, I guess.
Yeah, but look, there's things that you need to, take into account. Like what type of lens are they using? Is it lens distortion? Because if you have most lenses have lens distortion. So if the horizon's above the center of the frame, it's going to make it look like it's convex. And if the horizon drops below the center of the frame, it's going to look like it curves the other way. And in a lot of the footage that we see, if you watch it really closely, you'll see all of a sudden it looks like a globe. And then all of a sudden the camera will pan up and the horizon will be below the center of the frame. Now all of a sudden it's curving the wrong way. So we need to take lens distortion into account, all sorts of different things. Now, there's even scientists on the globe side, like astrophysicist Neil deGrasse Tyson there in the side chat,
Yeah.
and he's saying that he did the calculations, and he doesn't think that you would be able to see the curvature of the Earth from even 300,000 feet up in the air, which is twice as high as we can send a weather balloon. It's like 8 times, 10 times the height of a plane. He's saying that you wouldn't even see curvature from that height. So, that's something to take into consideration as well.
Yeah, sure. I mean, yeah, so I mean, I get your guys' points. Problem is, I still don't think the Earth is flat. I'm just, not ready with the documentations or like, the videos that I could send, but let me just check and give you like a reasonable documentations maybe.
Yeah.
Point.
This is the thing. We're not asking people to believe us. We have empirical evidence. We have all of this testing that's been done, and we're asking people to just look at it, look at the evidence, and then try to debunk it. Come to a logical conclusion based on the actual evidence. And the good thing about the evidence that we're presenting is you can actually go and do these same tests yourself. It's not something that requires any blind faith, right? So if you're saying,
Yeah.
oh, like we could look at the pictures from NASA, it's like, okay, well, I mean, you can't really ever test that. You're gonna have to take it on good faith. But these tests, for example, this is done in the real world. Okay, there has to be a certain amount of curvature over the surface of the water if the Earth's a globe, because of gravity
Yeah.
and the size of the Earth. So if you have a 20-mile distance, then there has to be approximately 266 feet of curvature over that distance, whether it's a lake or the ocean. It has to be there because gravity will be pulling everything to the center of mass, and that means that the water would have to be curving at a specific rate. And that means that, for example, if we were to shoot a laser or take an observation over a 20-mile distance, something that is in the distance should be hidden behind the horizon, depending on how high it is, right? So if you were standing on the other side of a 20-mile lake and I shot a laser across the lake, I shouldn't be able to hit you with the laser. It would be blocked behind a huge amount of Earth curvature, 200 feet of Earth curvature or something like that. But when we go out and do this test, I can hit a target that's 6 foot high on the other side of a 20-mile lake consistently.
Yeah, I want to check that as well, by the way.
Yep.
Like, myself. Maybe I will.
Yeah.
If I have time.
Yeah.
Yeah,
Right,
because
so
why
here's-
not? I just thought, like, at first when I saw this channel, I didn't even think it was really about flat Earth thing first, if I be honest. But yeah, I mean, I see that you guys have proof, and you guys are not saying, like, out of nowhere the Earth is flat. You guys have documentation, so yeah, I respect that. And let me just prepare mine, and then we can argue at the same level, because I see that you guys are really ready for this.
Yeah, man. Yeah, awesome.
Yeah.
Gather some data, come in, we'll have a friendly chat about it and go over it all.
Yeah, for sure.
And then we can present some of our stuff to you as well. And you can make up your own mind.
Yeah, for sure. So I'll see you guys later. I mean, that's actually conversation that I wanted to have. So I just had a better experience here with some other person. But I mean, if we argue like this for sure every day, I can just come check. But I'll see you guys later.
All right, man. Have a good one. See you next
Yeah.
time.
Bye.
Nice one, good cop. Okay, Spitter. Very simple. You told us about the distance to the stars. How did you verify this distance as either true or false? I don't want your copy-paste AI bullshit. I want to know how you confirmed those distances given.
You're dumb. This is the first thing, and the second thing, I use AI because my English is not that good, so I can't answer your question. If
The
I can't,
distance to the stars, you
Yeah.
said. I'm going to scroll
Wait,
back.
wait,
Let's
wait,
scroll back. Let's
okay.
scroll back. You typed it there. Don't be in a panic, my friend. I can read it out for you. Let's just scroll back. Keep scrolling.
What? Yeah. Why I can't see Burj Khalifa? It's maybe.
No, the Burj Khalifa has got nothing to do with your initial claim.
No,
Here
no,
we go.
tell me why?
Hold on, I'm helping
Why I
you.
can't see the stars?
How is it
Okay.
that we can see the stars that are millions of light years away, but we can't see the boat just after it's sailing away? Why? And I asked you
Actually,
the
I didn't
question.
understand. Can you type in chat?
That's what you typed. Oh, yeah, okay, excellent. So how about instead of talking, you just hold on for a little second. And then I asked you, how do you verify this distance as true or false. So you're claiming stars are millions of light years away.
Yeah.
How do you prove that they are millions of light years away? Whether that is true, whether that is false. How did you
Tell me then.
verify that?
Okay. Tell me then. The sun. Wait. Wait, please.
Take your time.
Okay, tell me how far is the sun from us? Can you tell me, please? Is it
We don't know.
100 kilometer?
We don't know.
I don't know. I think this is a dumb, dumb answer.
Why?
Because,
Why? I
bro, the
don't know.
sun is hot, man. It's not.
Excuse me, Spitter. Spitter, can you hear Jedi? Did you hear the fellow called Jedi? Did you hear him talking?
Who's Jedi?
Me.
Who Jedi? The guy that's talking. Not that one.
I just joined this server. What are you guys talking about?
We're having a discussion with young Spitter, and my good friend Jedi was trying to talk to him, and then you popped in. So how about you can be next, young Catherine, and you can ask questions then.
Friend, you're fucking dumb. Okay.
Excuse me, don't swear.
Stars millions.
Holy shit balls.
Man, years. You're
What's
fucking
going on?
dumb, and you think no,
Just
you're
mute him
fucking
and we'll
Spiraling.
move on.
Meltdown. He
Yeah, just mute him.
broke that. He broke that one. Wow.
Are you live right now?
Hey, welcome, Catherine. Sorry about that.
He was doing really well. There was potential there, but I don't know what happened at the end.
Oh well. Hello, Catherine.
Are you really in live right now?
Are we really what?
In live right now.
Yes.
In YouTube.
Yes.
Oh, great.
You can wave and say hello to your mother if you wish.
Hello, Mother. I love you.
Yay.
That's fantastic. Good to meet you, Catherine. How can we help you today?
Nothing much.
Oh,
Thank you. I appreciate it.
no problem.
Which channel are you in live right now? Huh?
If you see at the top of the channel list of names some YouTube bots, just click on those. It will take you to the YouTube channel.
Thanks. I clicked the link. Yes.
Good.
And welcome to Miku Boy. How are you today?
Hi.
What brings you here, my friend?
What?
Why are you here? Actually, I feel like the caterpillar of Alice in Wonderland saying that. I'm just imagining the smoke letters coming out of my mouth. Who are you? Oh, shit. That's funny. Oh, yeah, Clippy will do some nasty meme now. This is Matrix. So, Miku Boy, why have you popped in here today?
Trying to practice English.
Practice in English. That's a good idea, considering we're on the English server. Well, It just so happens the channel you've popped into, though, is the 24/7 Flat Earth Discord channel. So, what do you think about Flat Earth? Good, bad, somewhere in between?
Good.
Good.
Yeah.
What you guys are
So
thinking about refugees in Turkey, or like wherever you live?
Yeah, that's great, dude. This is a Flat Earth channel. Not the political, whatever you want to call it, channel. That's probably down and to the left a bit. But anyways, our good friend Miku Boy was telling us Flat Earth good.
Would you guys sink the refugees' boat if they put you in charge of the UK Navy?
What?
Or would you sink the refugees' boat?
What?
Can we have that in English this time?
Apparently not.
Hey, Twisties, where are you from?
What's up? Yes. Where do you think I'm from?
Well, we've got people that are from Africa, spent half their life in England, and are now... and all of a sudden you need to interrupt me.
Perfect, yes.
Yeah, how about we just make you be quiet? Just start talking halfway through someone's sentence. As I was going to explain to you, we've got some fellows that pop in here who are from Africa, who've lived in England some of their life, and now live in Japan. So, just because he's got a thick English accent doesn't mean he lives in England. So, that's why I asked you where you're from, because guessing is an absolute fail for some circumstances. So, again, Twisties, where are you from? I don't want your exact address down to the millimetre. Just a rough guess of Nigeria. Thank you. See? That's easy.
It's easy, yeah.
Shit, I was well off.
What about you? Where are you from?
My accent
Have a
doesn't
guess.
give it away?
Have a guess. Play some didgeridoo in the background, see if it helps.
I have an idea.
Uh-oh.
Oh. What's that?
Oh, someone has an idea.
If you look at the night sky
Yes.
if you're in maybe America, you'll see
Mhm.
certain stars. But
Yes.
someone in the southern hemisphere, like Australia, at the same time, cannot see some of those stars at all. If
Okay.
Earth were flat, everyone will see the same stars.
That's not
But
true.
since some
Yeah, that's not
stars
true.
are only visible from certain latitudes, this shows the Earth is round.
No. That just shows
Not
perspective.
true.
Why?
Hold on. I'll answer the question, my Nigerian friend. Can you put yourself on mute, please? So, you understand how perspective works, right? Things above your eye line, say the light directly above your head, you have to look up to see it. On the ceiling, on the other end of your room, you might have a light. You have to look up an angle towards it. If you've got a long corridor, you might have to look more horizontally to the light at the end of the corridor. This is how we see the night sky. When you look up, you see the star that's directly above your head. And when you look towards the horizon, you see the stars that are directly above that surface over there. So when you move towards that area over there, you look up and you see the stars that are above that area of that floor. It's literally, there are different stars in different locations. The reason why you can't see all of the stars from everywhere on the earth is because you have a relatively small field of view of the night sky. You can only see about 45 to 50% of it at any one time. That's just how the human eye works.
No. No.
Yeah, it is how the human eye works. Imagine
Near
you're standing in a
the
long where? No, okay, carry on, please.
equator, it's almost on the horizon.
Okay.
Your viewpoint changes because the surface is curved, not
No.
flat.
No, you've just moved. It doesn't matter if the surface is curved. When you go to a different region on this surface, different stars above that region of surface. It's got nothing to do with the surface being flat or curved. It's your position on that surface. Duh. So imagine you look up and you see a light above your head, and you look down a corridor and you have to point more horizontally towards that star or that light. That light isn't closer to the floor because you can go and stand underneath it and point up to it. Same thing with the night sky. You can stand in America where you can see those stars there, and then you go to a different area where there are different stars and you wonder why you can see different stars. It's because there are different stars there. Mind blowing.
Yes. My English is not enough to explain this.
Sorry, my English is terrible as well.
No comment.
Sorry, what was that? I didn't understand a word you just said.
I said my English ain't that good either.
No, still not coming through.
Yeah.
I'm an arsehole, aren't I?
Keep practicing your English, bud. You'll get better.
Thanks, mate. I'll keep trying.
I know it's hard for an Australian, but fair income.
Where does that phrase come from, dude? Fair dinkum.
What, fair income?
Yeah, yeah.
I don't know. But it only
And
sounds good when we say it.
Very unique. So there must be a story behind it. I need to find out.
I don't want to Google it.
Oh, even more, the position of the North Star changes depending on where you are.
Yeah.
So, near the North Pole, it's almost directly overhead, but at the equator, it's right at the horizon.
Yeah.
And if the
And it
Earth were
doesn't.
flat, the North
Yeah.
Stars would look the same,
No.
but it doesn't.
Okay, so again, it's again,
This is
English is
direct
your first. Again,
observation.
English is not your first
Anywhere
language.
in the world, no
Please don't
telling.
interrupt me, young lady.
Okay.
Thanks. English is not your first language. I've explained this 3 times. Stand in a room.
I
Point
don't
up
believe in you.
to the light above you. At the other end of the room, there's a light on the ceiling. Point horizontally across the floor towards. That's how your eyes work. You're
No theory
having the
needed.
light
Look at the
come in
sky.
to
Look
one
at the
point.
sky.
Why are you talking through me? You said English wasn't your first language, that you didn't understand, but you think it's a good idea that you talk through me. You will never understand, will you?
I'm
Do you like being told off?
I haven't debated with someone for like 3
And then stop giggling. I've explained this 3 times. If you stand at the North Pole and point up, there's a star above your head. If I stand in my warehouse and point upwards to the light that's above my head, as I walk away from that light that's above my head, still pointing at it, I will decrease the angle that I have to point up towards it until eventually I'm so far away, I'm pointing horizontally across the surface. That's on a flat surface. Do you understand now?
So it's not about pointing at stars. It's about which stars are visible and where they appear in the sky.
Yeah,
That
the
pattern only
pointing
makes
at
sense
them
if the
is
Earth
the
is
angle.
round.
Oh my God, you're just gonna fucking
That pattern
preach.
that just said That pattern only makes sense if the Earth is round. You.
Do you know what a
Not
protractor is?
necessarily.
No, you probably don't know what a protractor is. Why are
I
you
don't.
laughing? You do know what a protractor is.
I don't know.
No, you don't know, but you thought you'd laugh anyway. This is really simple to understand. I don't understand why you don't get it.
Are you trying
You
to
think
understand?
I understand it.
What do you understand about it?
He's saying that if we can be in North Poles or Australia, it doesn't matter where we are. We can point where the star is. But I think it's about which stars are visible and where they appear. The pattern
Yes. Okay.
that we
All right.
see in the sky
Yes, I get
only
it.
makes sense if the
It
Earth.
doesn't. No, that's not true. Okay, listen. You've got to picture this. You're in a big warehouse, flat floor, flat ceiling. Okay, there's a light in the middle of it, right? In the middle of the warehouse, and you walk under it. Okay, now that light is Polaris, right? We're going to call that light bulb Polaris. Now we're going to point at it, standing directly under it. Which way do we have to point? Straight up, right?
Yeah.
Now you can think of that as being your North Pole. Now you're going to walk several meters away from the light. Are you going to be pointing at it directly up now, or are you going to be
No.
pointing at it at an angle?
With an angle.
At an angle, exactly. So this is what Jedi has been trying to point out to you. Just like on the Earth, if you were to stand under Polaris, you'd have to point directly up at it. And then if you walked away some distance, you'd have to point at it at an angle, just like in the warehouse.
Exactly. The angle changes.
And the floor is flat in the warehouse, so it's not exclusive. That experience is not exclusive to curved surfaces. Do you agree?
Yes.
Right. Okay.
Thank you, T-Dub.
Anyways, whilst the young lady is contemplating that, in answer to your question, Jedi, dinkum appears earliest in the phrase fair dinkum in 1890 in Australia, but in 1881 in Britain. And it is not a separate word until 1905. It originates from the British dialects of Derbyshire and Lincolnshire, where it meant work or a due share of work. So if you did your fair dinkum, it meant you did your fair share of the work. Nowadays it means true, honest and genuine, and is often used accordingly. There are some who claim that the word was brought to Australia by Chinese miners in the gold rush era, from the Cantonese ding cam, meaning real gold. However, there's no historical connection with Cantonese, unless the connection occurred in the south of England prior to 1881 and was never recorded, which seems somewhat unlikely.
Give me back my phrase.
Fair dinkum? No fucking way. Ah, yes. So how did our young friend go with her lights in the sky?
Oh, I have a second idea.
Oh.
How do you
What's that?
think we have angles?
Angles?
Yeah. You said
Angles.
that
Yeah.
we're we're seeing stars in different angles because we're in different countries. You said that. So why do you think we have angles?
Why do we think we have angles?
Yes.
Well, when we're talking about the star directly above your head, that forms a 90-degree angle. You point straight up to it, that's the vertical, whilst you stand on a horizontal plane. An angle is two straight lines that meet at a point. You, the observer, are the point. Now you see the horizon and you see the star. The angle is the elevation angle of the star above the horizon, or the light above your head on the ceiling.
But if we were on a flat Earth,
Yeah.
the surface will change or not
Why?
change, or angles. Because
Right.
on a flat
Okay.
Earth,
Yeah.
the stars will all stay in the same positions no matter where you are. The changing
No.
angles you observe prove the
No.
surface you're standing on is round,
No, that's
not
not
flat.
true. It's not true. First of all, we observe the difference in angular displacement as the stars across the sky. Secondly, I'm just trying to tell you how you see the world. Now, you can demonstrate this by standing in a hallway or a large warehouse with multiple lights upon the ceiling. You'll notice that you would have to point at different angles towards those lights. You will have one directly above your head. This is a 90-degree angle, by the way. Vertical angle, you point up, standing on a horizontal floor. As you move away from the lights, still pointing at it, you'll notice your arm starts to go down because the angle decreases. It's just perspective, how the human eye interprets light that comes into it from different angles.
It's my turn, I guess. On a flat Earth, this the fact that the angle of stars, you said the angle of stars as we look at the stars shifts with your location isn't a flaw in my argument. It's
Yes, it
the
is.
proof itself.
No, it's not. It's not exclusive to a sphere. Both of these things doesn't matter the surface. I'm pointing out to you the alternative. You seem to think that only happen on a curved surface, which just isn't true. You stand on flat surfaces noticing lights above your head all the time and pointing different angles towards those lights. You might even move across that flat surface and have to point at a different angle towards that light. Doesn't mean that your flat surface is now curved because you can only observe that on curved surfaces. It's because you moved.
Actually, it's a principle by which we can calculate the height of certain things like mountains, or even trees, a flagpole, right? So if you know your distance from it and you know the height, right? Sorry, if you know the distance from it and you measure the angle to the top of it, right? You can use those two variables to calculate the height across a flat surface. Right? This is actually what they use. They used in this in surveying. This principle. It's trigonometry and planar geometry. It's not involving sphericity of a surface.
Every time you say that you can't change your angle on a flat surface and it only works on a curved surface, that's defying the definition of an angle. Curved lines don't make angles. If you're on a curved surface like a sphere and pointing up to a star, you're not making an angle, are you? I see Nevsky is posting videos in the chat. I don't know if Nevsky's got the ability to speak, but you're more than invited to speak about the information you posted in the side chat and tell us why flat earthers are dead wrong, as the thumbnail says from the infographic show. That'd be interesting. Nevsky, you appealing for us to watch the educational video. Maybe you could describe the educational video and tell us how it educated you that the Earth was there. Being as you're giving it as your evidence, come speak about it.
That is a great idea. Nevsky, you're up.
I don't like it when people just throw on the side, watch this and then run away. It's like, no, this is your evidence. You can speak about it. You can show us how it proves your claim or that we are dead wrong. Unless you're scared of it. I'd be like, whoa, this is my evidence. I'm going to smash all over the face with it, not run away from it. So, after you, Nevsky.
Yeah, if it was my evidence, Jedi, I'd be lighting up a cigar, putting me boots up, grin on me face like a Cheshire cat, and having a great old time.
Yeah, obviously you watched it and you understand how it debunks flat Earth, so you could actually summarize it for us. You could put it into your own words, I'm sure. You're smart, right? As was pointed out to you in the side chat by Old Dude as well, off the get-go, off the bat, the video has a thumbnail which is a straw man of our position. It's a misrepresentation of what we're saying. We're not saying that Earth is a disk in space. That's not what we think. So what is it arguing against? An imaginary flat Earth that they've made up for their opponent? That's what a straw man is. So it's already beginning. The video begins with a logical fallacy called a straw man. Misrepresent your opponent's argument so that it's easier to burn down. Right? What have you got to say about that?
The time is different everywhere, according to Nevsky. No shit, that's because the sun moved. Ever heard of a sundial? As the sun moves across the Earth, depending on your location, you can measure its movement across the sky in angles. This is why the time is different. The sun moves. Same thing in your model. The sun moves across the sky, but your reason or cause for that phenomena is the Earth's rotation. Still, same phenomena in the sky. The sun's moving across the sky. So we just say the sun moves across the sky. It's quite standard time that usually comes from the sun. Go figure out what a sundial is.
Right, at 1 minute 32 into the video, this, whatever the hell that is, on top of elephants on top of a turtle, is shown. Nevsky, or Nevsky, however you say your name, do you honestly think that's what us as flat earthers, do you honestly think that's what we believe? That is what is happening? That there's some mystical, magical turtle that can carry elephants that hold up the entirety of Earth and fly through space? Is that what somebody has told you that we are selling? Because if that is the case, I'm here to inform you, this is incorrect. This is an epic failure. I do not think that crap. And I'm quite confident in saying no other flat earther in this room thinks that stupid cartoon thing that I clipped out of your video thinks that shit. They'd check themselves in if they did. I'm quite certain of it.
Well, that's not even a flat Earth. It's got a curved top, like a mushroom. Come on, bro. Nevsky, why don't, instead of assuming that as flat earthers we agree with everything that's being said about flat Earth in that video, right? That we agree with it. Instead of assuming that, why don't you ask us if we do? Why don't you ask us our position? Why don't you ask why do we say the Earth is flat? It's not nice to just assume that we take a position held and represented, by some video you saw. That's not fair. We may disagree with that. All right, Nevsky, it's time to mute up. I don't know what is going on today, why we have so many that are insistent on just using the side chat and won't mic up and VC with us and talk with us. I don't know what's going on, but it's getting boring. You obviously understand English well enough to be able to respond in the side chat to the things that we're saying in the VC. So I'm assuming, justifiably so, that you can speak English well enough to communicate with us in the voice chat. So please open your mic or give us a damn good reason why you can't.
Catherine's looking for some support in the chat globally. She's asking, is anyone here who believes that the Earth is round? If you could all put your hands up. She's looking for some comfort at the moment.
How about I ask, is there anybody here that believes in the globe Earth? Please put your hands up by opening your microphone and saying yes. And if you don't, I'll remove your text privileges. I'm getting really tired of this side chat nonsense. Open up your microphones. This is the opportunity for you to speak English. If you don't speak English well enough to have a discussion about this, then maybe you should go to the beginners or intermediate channels and learn a bit more and come back. Because that's the purpose of this channel.
I don't understand Nevsky. He's, I think, saying that the Earth's outer layer that protects us, probably meaning the atmosphere or the crust, is shaped like a perfect sphere, like a ball. I don't know.
You'd have to ask him to explain that. The protective layer of our Earth is a perfect sphere. Don't know what he means by protective layer. Or she. I haven't got a clue.
I think the Earth is almost a perfect sphere, but not exactly.
Okay. So if there's a curved surface, would I be able to measure that curved surface?
It's I can't explain. I'm trying my best. Oh my god.
It's like saying there's a 45-degree angle. Okay, so I'd be able to measure that 45-degree angle then. And you'd say Yeah.
So, when a ship sails away, the bottom disappears first, then the top. On a flat Earth, it will just shrink evenly. This shows the surface is curved, the Earth is round.
And you've seen that
Debating.
before, have you? You've seen this, what you're talking about before, with your own eyes, have you?
I'm trying, okay?
Please don't get defensive. I'm just asking. What you just spoke about, the boats disappearing bottom up. You've seen this, I presume. Yes? No?
Yes, the bottom
Okay.
disappears.
Was this with like the naked eye? Did you have binoculars, telescope? What optics were you using?
Just my eyes.
Okay. See, we've gone out and used high power optics, and that boat you can't see, we see again. See, you think that you can't see the boat because it's gone over the curve of the earth. We get the high powered optics out, and there's the boat again, showing that it didn't go over the curve of the earth. You just can't see it because your eyes work in a specific way. That's why we get technology to improve how far we can see or resolve those angles at distance. So next time, get a camera.
I think camera shows that. The flat is the bottom disappears and the top.
Okay. I'll give you that sometimes it might look like the bottom of the boat is disappearing. This is due to the atmospheric conditions. You can make this happen on flat surfaces if you have heat and pressure and density in the air that you're looking through. This is what causes miraging,
So
inferior,
you
superior.
don't think that every ship
No, shit in him.
every ships don't do that?
No, they don't. That's what I'm trying to point out to you. It's
How?
meteorological conditions, as I was just saying, through me.
In science they say that too.
In science, they say atmospheric refraction causes things that you have a direct line of sight to appear to sink upon the horizon due to the meteorological conditions. Scientifically speaking, you understand what I said? Scientifically speaking, you can have a direct line of sight to something, but it looks like it's sinking because of the weather. Scientifically speaking, do you want a paper? And like I said, where you think that the boat disappears with your human eye, then I wouldn't be able to see it with the telescope or binoculars because it's over the curvature of the earth. But when we get the binoculars or the telescope or the camera out, we see the boat again.
You say science say that, but they can't explain the full pattern.
You're not listening to a word I'm saying, are you?
Every single time, even on perfectly clear days with calm water,
That's not
refraction
true.
might. Let me speak.
No, you're
Refraction might
lying.
make refraction might
I've
make
seen
things
this
look a bit
myself.
wavy or distorted, but it never makes the bottom vanish before the top. That
Have you got
consistent
Google? Have you got Google?
Yes, you.
Cool, awesome. Can you type into it for me?
Okay.
Atmospheric refraction sinking.
I'm
And
typing.
then when you've done that, read it out to us. Read it. Because I know what it says.
I don't agree with this.
Oh, now you don't agree with what the science says because it doesn't fit your narrative. But this is what the science says.
Yes,
Do you
yes.
dismiss what the science says?
Because atmospheric refraction can slightly bend light and make objects appear a bit
Hello?
higher or lower, but it cannot create the consistent pattern we see.
Sinking.
Yes, it does.
Atmospheric refraction sinking. Google that specific term, sinking, please. Or are you scared?
What's your native language? What's your native language?
Turkish.
What is your native language? What is it?
Turkish.
Sorry, does anyone else understand? Turkish. Okay, all right. I'm going to post a citation for you in Turkish so that there's no reason you
A
can't understand it.
phenomenon where
Okay?
distant objects appear
Okay.
lower than their actual position due to a steeper than normal air temperature decrease with height. I don't understand anything. Because refraction only slightly distorts image. It cannot mimic the effects of a curved surface.
Okay. So would you like to see more observations of what you think the horizon is? Because at the moment I'm trying to show you that, scientifically speaking, you can make things appear to sink when you have a direct line of sight to them. That means there's no, in your world, no curvature of the earth between you and the boat. But it looks like the boat is sinking into the horizon. That's just due to the meteorological conditions. Meteorological conditions can cause the object to look like a few things. And that's
But
all I'm pointing out.
Normal consistent, like in normal weather, how the boat is sinking.
In normal weather, you'd have to show it to me in normal weather because I think you're just making claims. What is normal weather?
Like sunny weather.
Okay. What's the density and temperature of the air and the surface of the water?
So you say every weather is just making the boat sinking partially?
No. I'm telling you that when we make these observations, this sinking doesn't happen all of the time. There are different things that happen depending on the different conditions of the day. Now, the point is we shouldn't even see the boat, but we do. This is one of the main reasons why we're here as flat earthers. We go to the beach with cameras and we watch boats and distant like lighthouses and windmills, things that are very, very far away, things that we shouldn't be able to see if the surface of the earth was curved. The thing is, we see them. They're there directly in front of us, showing that there is no curve to go over.
Maybe different weather may make the top of the ship bend a little. I don't know, but I haven't seen anything that makes the bottom vanish before the top.
You've just read the citation. I've asked you to Google it. And it gives a very clear description of the phenomena that is caused. Now you're just walking away from it like I didn't even say the words. That's
Yes, Google or other sources might say that, like refraction or weather can slightly change what we see, but that doesn't explain the full consistent effect. Like the bottom of a ship disappears first and the top last every single time, even on purpose.
All right, sorry, this is annoying. It doesn't, not every single time, because I've done these observations and the boat doesn't always go over the horizon describing. Sometimes we see the boat 30 miles away from about 10 foot above the surface of the water, where we should have lost sight of it after. Now, why do we still see the boat 30 miles away? We shouldn't if the surface was curved, but with the right technology, we can point at the boat, it's directly in front of us. We can wave at it if we want to. I don't think you've made enough observations to turn around and tell me it happens all of the time without exception. That's a bold claim. It's a lie, but it's bold on your behalf.
Well, if it does, she's throwing out looming refraction. What happened to looming? Because we would show you, right, an observation where something is visible beyond the physical geometric curvature of the Earth, and there's no horizon there where it should be. Just see clear for miles and miles and miles with like an object, like an oil rig, just sitting there in full view, not being blocked by any curvature when it should be blocked by feet, tens of feet of curvature, or if not completely hidden, right? And you'll say, well, that's refraction. Oh, but you just said a little while ago, oh, we can raise or lower things a little bit, but not like that. But if we showed you an observation, I bet you'd soon say, yes, like that.
Catherine, how far away do you think the horizon? Catherine, are you still with us? I like your surname, by the way, Pierce. It's very British. Guess it's back to silence, T-Dub.
No, I said my arguments, and you just said no, so.
Okay. Do you see the image that I posted? Do you want to have a look for me?
Where?
In the side chat.
Oh, yeah.
Okay. Do you see the image of the oil rigs?
Mm,
So 21 minutes past the hour. I only posted it to
is it a true image?
Yeah, it's image taken from a video. This is the type of thing that you can recreate yourself. You see the image, right?
Yes.
Okay. How far away do you think the horizon would be standing at the beach and you're 6 foot tall?
I don't know.
Okay. Well, we're told how far it should be with the radius of the Earth and the height that you are above that surface. The horizon for a 6 foot observer is going to be about 2.8 miles away, just under 3. Now, the image that I posted is an observation height of 8 foot above the surface of the seawater. The oil rigs, we know how far away they are from the observer. I think they're about 8 and 10 miles away, 7 and 9. If we were living on a sphere with the radius that I said, then the horizon would be at 3.46 miles away. Just to be clear, that's in front of the oil rigs. Now, you, like everybody else, can see the horizon past the oil rigs. So we can say that the horizon, is about at least 10 miles away. If we're on a planet, the horizon should be at 3.46. But we can clearly see the horizon beyond 10 miles away. We shouldn't be able to see the bottoms of the oil rigs, but we can. You'll notice as well with the image in the GIF, the person is zooming in and zooming out. When he's zoomed out, you can only see the horizon. You can't see the oil rigs until you zoom in, and then you see the oil rigs and the horizon extend past the oil rigs. So when you say, I can't see the bottom of the boat because it's going over the curvature of the earth, this image shows you that that's not true. Because if it was true, the horizon would be in front of the oil rigs, wouldn't it?
Wouldn't it?
Yeah, it would. It's just a very simple mathematical equation to figure out how far the horizon is on a geometric shape, a circle or a three-dimensional sphere. If you know the radius, then you're going to know your height of eye is going to tell you how far away the horizon is. Very simple math to do. You can find it in any Earth curve calculator online. You can Google one if you want to. It gives you a distance to the horizon. In this instance, 3.46 miles away. But it's not there, is it? It's beyond 10 miles away. Now, this is just one. There's hundreds and hundreds of these long distance observations, let's say. There's hundreds and hundreds and hundreds of measurements of the surface as well. But being as you spoke about boats and then disappearing bottom up, I thought you should show this because the horizon should be blocking the front of the oil rigs, but it's not.
See, now you're going to need it to be more than slightly to explain this. So are you going to take that statement back? Oh, only slightly. It only changes it slightly because you're going to need it to change in orders of magnitude to explain what Jedi has just shown you. So do you want to take that back, that it only changes it slightly?
I think the video, I don't know, the geometric horizon for an observer, you say that 8 feet high is about 3.5 miles. Am I correct?
Yes.
But the visible horizon can be much farther, around 10 miles, because of atmospheric refraction.
Did you Google that?
Light bends slightly
Catherine,
in the air.
I'm going to ask you a very simple question.
I
Where
said
did you get the atmospheric refraction from? Did you Google this or did somebody send you a message?
Yes, I googled it.
Yeah, we can tell
Thank
because
you.
it sounds like you're reading.
Light bends slightly in the air.
Listen, I want to pull you up right now because now you're contradicting yourself. Is it slightly or can it affect it slightly or affect it a lot? Yes or no? Slightly or a lot? Which one? Slightly or a lot? Which one?
I think it bends slightly in the air.
Slightly. Well,
How is
okay, that's not
100%
explaining.
increase slightly?
That is not.
How
One
is
sec, bro.
5
That's
miles to
one
10
sec, bro.
miles
One sec, bro.
slightly?
One sec, bro. One sec, bro. That's not explaining 1.22 miles to 10 miles. That's not slightly.
Much
That's
farther.
not one from 1 mile to 10 miles is not slightly. I'm sorry, you need it a lot. Now you just read out that it can extend it a lot, right? So what you're reading is contradicting what you said about it being slight. So you have to pick one. It's slightly or a lot. If it's slightly, then what you're reading is incorrect. If it's a lot, then what you said earlier is incorrect, that it's slightly. So which one are you going with?
Yeah.
You have to choose one here.
It can bend light. Yeah.
A lot or slightly?
Oh, right, it is.
Yeah, sorry.
Yeah, no.
See, even with what you googled and read out to us, we've gone out and
Because you Google and write in the chat, so why not? I will not
no,
read it.
it's fine. I want you to speak. I'm just going to say that you've posted, we've tested, and what that says isn't true.
The Google is not true.
No, that light curves around the curvature of the Earth. No. Now, light will deviate towards the denser medium depending on where that denser medium is, and that denser medium is going to depend upon the amount of moisture or water vapor and the temperature.
I'm going to say can I finish? Even with refraction, the bottom disappears first every time.
Okay, when you say every time, or in the image that I showed you, because the horizon should be making the bottom of the oil rigs disappear every time, but the horizon's beyond the oil rigs, so not every time. You understand, right? You're saying it happens every time, but I showed you it not happening once. I can show you it happening 100 times. So you must concede it doesn't happen. If the boat disappears over the horizon and if the boat is blocked every single time, then the bottom of the oil rig should be blocked. Why is the bottom of the oil rig not blocked? And if you say refraction, that's you conceding that not every time. You're between a rock and a hard place. So which is it?
Yeah, a lot, a little. It happens every time. It doesn't happen every time. The reason that you're appealing to refraction is because it doesn't happen every time. That's why you're saying refraction, which is what I said you do. This is what I said earlier, that exactly what you do.
Oh, I got an idea. Hey, let's give you the benefit of the doubt here. Let's say it is that. How far would the horizon have to be for you to think, oh no, that can't be refraction? How far? What distance?
Okay, doesn't matter. You know what else we could show you? We could show you replication of this over smaller distances, over flat surfaces, where there seems to be an apparent bottom-up obstruction when there isn't. There isn't one, but it looks like it is. Would you like to see some of those?
Yeah, good question, both of you guys. Orion questions, I kind of like it because there should be a tolerance when they say, "Oh, it's refraction." What we're seeing is refraction. That's why you can see afar. What will be the tolerance? Like, is it like you know what I'm saying? Like, Orion question can be probably explained a little more. And he should get a reply, I think, in that question, and hit up as well.
Hey, Catherine, in the side chat, there is an image of two coffee cans, a top one and a bottom one. Can you have a look at the bottom one, please, and tell me if the very bottom of the can is missing?
Yes.
Excellent. That's what we call bottom-up obstruction on a flat surface. So if things are disappearing bottom-up on a flat surface, that means that it's not curvature that's the cause in your cause and effect relationship. That means something else is the cause.
So if we look down, we can
So
see.
how about we address the cans? 2 cans taken from the same distance. The only difference is camera very close to the ground in one and raised up in the other. The bottom image, where the camera is close to the ground, shows the bottom of the can missing. There's no curvature in that. So you claiming curvature is false. You claiming refraction is false. So I just dropped out for a second. You claiming that there's curvature is false because it's on a flat surface. We know this. You claiming refraction is false because it's only 21 feet away, 22 feet away. So there must be some other cause for the thing disappearing bottom up.
But you're still seeing the whole can, just visually shifted or distorted.
The bottom of the can is missing. This is what you're claiming when boats disappear bottom up. The bottom disappears and we can still see half the top.
Calm. When I first look up the image, I can't directly see the bottom. But
in the can, we can't directly see the bottom.
When I look down, I see that.
What do you mean when you look up, when you look down? You're at the beach. You're looking out at a ship sailing away.
The bottom doesn't
right?
just
You're hold on. Hold on, you're about to explode for no reason. That's not necessary. You're at the beach. You're looking at a ship sailing away. The bottom disappears, doesn't it? That's what you're telling us. You think bottom disappear because of curvature. The purpose of the cans is to show you bottom disappear with no curvature. That's why.
I don't agree.
Well, whether you agree or disagree, the fact of the matter is we know that that floor is flat. We can all see the bottom of the can has disappeared. So, let's think about what possibilities it could be. Is it curvature? No, it's not, because we know the floor is flat. So curvature is not the cause.
But with ships, the bottom doesn't just distort, it completely disappears behind the horizon.
No, it does not.
It's an earth curve.
With a
Sorry.
zoom, you
Hello?
can bring it back.
Catherine?
Hey, Catherine, stop. You're assuming the horizon is the curve. I've already demonstrated with the cans there is no curve. We can make things disappear bottom up with no curve. So that means that the cause is not the curve, because in that image there's no curve. So there must be some... listen, you're not listening. So that means the cause has to be something else. It has to be. The reason it has to be something else is because the can is disappearing bottom up. You can see that. You told me it was missing.
The object is still there, yeah.
That's because it's not far enough away. We haven't gone backwards enough.
Because we changed our angle.
Because no, we haven't.
Hold on, you've got two images. One's higher, the other one's lower. That's a change in angle.
Both of them, same distance away from the camera.
Mm-hmm.
Why is it she can understand ships disappearing bottom up, but she can't understand can disappearing bottom up, and there's an image of the bastard on the screen?
Because Google says.
Let's try something else. Where's my ship picture? Get the SS Globetard out.
SS Globetard.
That's what it says. Right. You're laughing. Zoom in on it. Catherine, can you click on the black image with the coloured lines? Yeah, you saw it, didn't you?
Yeah, sorry.
Can you see the image I'm talking about? Catherine, she's still there? Oh yeah. Catherine?
There's somebody in the side chat called exclamation mark. If Catherine's disappeared, Matrix. An exclamation mark says, I've not heard a compelling argument in favour of flat Earth, and I've searched for years. Oh.
I'm here.
All right, we'll deal with Catherine first. Catherine, in the side chat, at 42 minutes past the hour, there is a black image with coloured lines on it.
Yes, yes.
Can you click on that image? Yeah, that's the one.
I clicked it.
Yep, so you saw the little ship there.
Yes.
Excellent. Right, that's the one, yep. Okay, at the left-hand side, that's you, the little tiny stick person standing there. On the right-hand side is the ship. Now, that yellow line is your line of vision, your line of sight from your eye, directly horizontal. The white line is where your vision meets both the ship and the water at the same time. The purple one is your line of vision to the top of the ship. Now, this is where it's going to get somewhat technical. Each one of those lines, your eye line being the yellow one, down to the bottom one, the white one, makes an angle. The one between the yellow one and the purple one makes another angle. Now, we have a thing called angle of resolution. When that angle gets down to 0.02, you cannot resolve the image. That means your eyes can't focus on it properly. They can't distinguish what it is in comparison to the surrounding environment. Okay, so as the little red ship sails away from you over on the left-hand side, so the ship sails away, those two angles, the top one and the bottom one, which one is going to get smaller first? Which one's going to get down to 0.02?
Bottom.
The bottom one. That's correct. That's 100% correct. So what will happen is the ship will sail away, and due to perspective, the ship will appear to get smaller. And as it appears to get smaller, your angle of resolution gets smaller and smaller and smaller as the ship sails away. And eventually, one of those angles is going to get to 0.02. And when it does, you can't resolve that image. Now, you've already told me the bottom section is going to get to 0.02 first. That is correct. That's why the bottom of the ships appear to disappear first.
But your diagram assumes light travels straight, but in reality light bends in the atmosphere.
Oh
So
shit, is that going to cause the bottom of the object to appear to disappear first then?
I think the
So
model
that'll be the light that we were speaking about earlier, deviating through the atmosphere that can cause the object to look a certain way. Even it may look like the object is sinking into the floor. Are we back here again now?
Am I the only one who believes this in this whole debate?
You're the only one brave enough to talk, so you've got our respect. Everybody else is too cowardly, so you're better than those people. Well done.
I'm brave enough to talk. However, I'm respectful enough not to interrupt. Don't
There
get
we
mixed,
go.
thanks.
Sorry, guys. I knew I'd stir the pot. Welcome, everybody. I think this young lady's looking for a little bit of support. So, if one of you gentlemen want to step up, I'm sure she'd appreciate it.
I can't
Is that right,
support.
Catherine?
It's been nonsense so far.
Okay, what do you want to talk about then, my friend?
Me?
You want to talk about you?
No. I mean that the observed horizon is complete nonsense with this atmospheric refraction. It makes no sense with the math.
I know, it's terrible, isn't it?
Yeah, I'm starting to see.
So, apart from that, my friend, or anybody else, has anyone got any questions or points of view they'd like to raise? Does somebody want to defend the idea that the Earth is a sphere? If you do, please unmute yourself. Catherine is looking for some backup.
I was hoping that exclamation mark would call out, "I'm Spartacus," but he didn't.
Exclamation mark, you are free to speak in the VC. Just need to unmute yourself and say hi. The name is apparently Sexy Vegan. Okay.
He's the original sexy vegan, actually.
Really?
How would satellites work? I thought about that last night. Do they work? Is there any way to have some shit float above the Earth in so-called orbit?
I'll mention this, but only because I've seen it and NASA tells us. So this is free information that you can find on nasa.gov. There are multiple ways to keep things up in the air. One of the technologies that they've used since the 60s and specifically the 70s through the 80s is a technique called electrodynamic tethering. Because of the electromagnetic environment high up in the sky, there's a lot of energy potential. If you were, and as say for example the shuttles used to do, were to extend an aluminium-like aerial or tether out the back that was about 500 meters to a kilometer long, then you would pick up the voltage of the surrounding environment. This would give you motion. This would also give you power. So maybe look into electrodynamic tethering from NASA.gov. This is what they tell us. I don't know about satellites, my friend, but they tell us that one of the ways that they keep satellites up in the sky is by the technology that I've just described.
So that's basically they're using static electricity in the atmosphere, in the air.
Yeah, I think so. I don't think it's static. I'm not too sure. It's been a while since I've read it.
Kind of like when you take a broom, you brush your hair and then you put it close to the water stream, and then the stream bends. Clear
I think of it.
traction
I
right
think
there.
of it like bumper cars or dodgems that you have at the fair, where they've got an aerial that reaches up to the electrified mesh in the ceiling, and you can drive the car around that's powered from up above. Kind of think of it a bit like that.
Yes. Yeah.
There's other things like quantum locking. You get certain substances, make them really, really cold, and they appear to levitate. You can put them in motion and whatnot. Again, these are demonstrated, but I don't know the specific, if this is specifically what satellites are.
Yeah, I've seen that, but for that you need both temperature control and magnets.
Yeah, exactly.
Okay. I mean, the images are just clear as fucking day. It's fake, man. I see no reason why they would fake these images from the new so-called space shuttle.
Are you talking about Artemis? Yeah.
Yeah. It's laughable. It's fucking laughable.
I'm taking it that you're not impressed, are you?
No, I saw the first photo. I was like, okay, yeah, I can fuck with that. And then I saw the second photo, apparently 12 hours later, and then I was just, no, the gut feeling was right. It feels altered to the fucking limit. So yeah, that was laughable. It was laughable. It's literally the same image. I mean, it seems pretty clear that atmospheric refraction, even by their own calculations, should not account for me viewing Visingsö from Jönköping in Sweden, which is 25 kilometers straight water. Even possible at all.
A lot of these clowns will use refraction as a get-out-of-jail-free card. It's so they can make their claim non-falsifiable. But here's the issue.
When you look at the numbers, then it does make sense.
That's right. But the issue is, as soon as they use refraction as their get-out-of-jail-free card, they drop all and any claims to a physical horizon, because now they're just measuring bendy light, not the actual ground.
Yeah, but it still makes sense, because they mean that the bending light is bending with the bending
Well, it's
ground.
just a claim. They can never give you the numbers on how it's bending and at what range that it's bending. They never ever give you any data to back up the claim of the bendy light. It's always just refraction. That's it. You get one word. And that one word is very vague. It covers quite a few things.
Given. The numbers are given online, but they don't make sense. They don't make sense with the oil rig. They don't make sense with Jönköping in Sweden.
Well, let's just break it down. Let's make it make sense. With the oil rig one, if they claim standard refraction, 7/6R, let's let them have that. So instead of the formula being 1.22 times the square root of the observer's height in feet, the formula now goes to 1.34 times the square root of the observer's height in feet. So the original black swan at 1 foot of elevation, the horizon now goes out to 1.34 miles. So have a look at the 1.34 miles and have a look where the horizon is.
Yeah, that's what I mean.
Horizon in
They
your
don't add
eyes.
up.
See ya, guys. Hi.
Yeah, I didn't get that. Yeah, sorry.
Yeah, man, and I remember I could clear as fucking day view Visingsö, which is in the middle of this lake, the second largest lake in Sweden. Clear as day, I could view it from the shores of Jönköping, which is exactly 25 kilometers away, which is... How much is that in miles? That must be like 18 miles or
About
fucking...
17, yeah, 17, 18
Yeah,
miles.
17, 18 miles, something like that. Which makes no fucking sense at all. And this was also in the winter. And the summer. And every fucking... always. Doesn't make sense. Like, the numbers doesn't make sense even going by their own numbers. So-called Glober's numbers. I'm not taking sides. I'm not saying you're right, they're wrong, or anything like that. I'm just saying that it's very sus. The numbers are lying in this case. And I mean, the picture from NASA, it's 2026, man. Why the fuck would they fake a picture of the Earth?
Yeah, who knows? Hey, which lake was that? Vättern?
Yeah, exactly.
All right, cool. Yeah, I've been there. It is. You should not be able to see the other side if Earth had a curve to it, but it doesn't. So that's why you can see it.
No, I didn't see the other side of the lake. I saw the closest part of Visingsö. There's a small island in the middle.
Oh, okay.
Well, it's not so
Yeah,
small.
all right, I see.
It's
Yeah.
an island in the middle of Vättern.
Okay, and you could see the
And
lights there.
that's... Yeah, you could see the whole fucking island, man.
Yeah,
It's like...
You shouldn't be able to do that. So there you
And
go.
that's 25 kilometers shore to shore.
Right.
Southern part of the island to the northern shore of Jönköping.
Yeah, you know,
25 kilometers.
I'm from the south, and you shouldn't be able to see Copenhagen from Malmö, but you can. You see the white beach on both sides there. That's only 16 kilometers, but there should be 20 meters of curvature between those two countries, and there isn't.
Wait, what? There's fucking... It's only 16 kilometers between Copenhagen and Malmö?
From the beach, well, Denmark, and I don't know exactly the... Copenhagen is pretty big, right? But that side, you can stand down by... have you've been to Malmö, haven't you?
Yeah.
Yeah. Just look at the map there. You see it's about 16 kilometers from beach to beach between the turning torso beach over to the other side, kind of diagonal.
I thought it was longer.
Well, not where I was. But there are many places you can go check it. And on the other coast, you can see Öland from Kalmar. That's only 6 kilometers, but still, when you're sitting down, you shouldn't be able to see the beach on the other side. It should be
Yeah,
like...
and I'm thinking spontaneously, Visingsö, the small island, well, not so small, but the island in the middle of Vättern.
Yeah, that would be fun too.
It's not a high island. It's not like fucking big hills or mountains and shit. It's very flat, and I could see the whole island. Like, in my head, with the curvature, it should 24 kilometers. I shouldn't have seen anything of any of it. Sitting down on the beach of Jönköping.
It happens all the time. People just don't... They're not used to connecting it.
I thought about it yesterday, and I was talking to DJ, and I told him I wasn't sure how far it was, so I went into the satellite photo and measured, actually. And I was surprised it was 24 kilometers, but it made sense, you know, Jönköping to Gränna, which is a city along the shore, along the, like, about the same distance to the island, over the water, but on road, which is also about 30 minutes by car, which is about 24 kilometers, 30 kilometers.
Yeah, is that thing along the E4 Pretty sure it is.
Yeah, Gränna, on the right side of Vättern.
Yeah.
That's where you take the ferry over to Visingsö. And that ferry distance also is like 7-8 kilometers. And you could literally see the fucking, you know, the entrance and the exit for the ferry. Even.
Yeah. Yeah, well, that's the way it is. Welcome to Flat Earth.
Yeah, I'm not welcomed just yet, but the
Well, you have,
curvature is off.
at least you know water
mean-
doesn't curve. That's the first step.
Well, at least not by the calculations that
they say
are given.
Yeah,
exactly.
So Earth radius 6,400 kilometers.
Can I say something?
Yeah, go ahead.
New guy. Sorry.
Who's
What's
that
your
me?
name? Vegan. If you realize that at the bare minimum, the Earth radius that they tell us is a lie, and you do some research into the equations they give us for all our motion, those equations only work for the globe of the radius that they give us.
Which equations are those? Are you talking about?
You know, like Newton's law of gravitation. Anything that
No, that
uses,
has nothing to do with the curvature, the radius of the Earth. That's the little g. That's the acceleration of the
which is based
so-called
off of the
gravity.
radius that they give us.
What? No. The acceleration 9.82 meters per second squared is only an average measured all over the Earth. It has nothing to do with the radius or the shape or anything. It's just an average measurement.
Yeah, but that acceleration only works for the specific size that they gave us.
No, it doesn't.
I'm not sure
They
that
have
the shape has anything to do with it, actually.
no, the shape has nothing to do with the acceleration of so-called gravity. It's only an average of measurement. Now, they have done associative equations to then, to have a relation between the size of any given planet and its the mass of any given planet and the size, of course, and then the relation between that, the size and the mass, and then the so-called gravity for this planet. That's why we have calculations for the gravity of the moon, and why we have calculations for the gravity of Mars. That's just an assumption of an association between the mass of the so-called sphere and the acceleration we have measured on Earth. I mean, the radius could still be pulled straight out of the fucking ass and put in relation to the 9.82 average measured.
No, but
and
my
then
point
boom, you have an equation.
is they
very simple.
calculate our gravitational acceleration using the formula G big M over R squared, where R is the radius of the body.
No, that's backwards. It's literally the other way around. The 9.82 is
9.81.
Well, it depends on where you measure or how you round up. That acceleration is an average of measurements of a measured acceleration, and then in a vacuum, of course, without air resistance.
Yeah.
How did we slip into gravity anyway? What's the point here?
He's trying to say that we must have a radius of the Earth, or correct me if I'm wrong, Russian guy. I'm going to call you Russian guy because I don't know what your thing says. I think he's trying to say that we must have a radius of the Earth in order to have a calculation of the 9.82 meters per square second.
Well, you don't need it to measure it, but if you're calculating it, you do.
No, you don't.
Yeah, you do. It's
That
from
could
Newton's
as
law of
well be a
gravitation.
made-up equation. That could be a made-up equation.
It is a made-up equation.
Yeah, well then again, the radius could be pulled out of their ass. How would you know it's actually
Exactly my
real?
point. Exactly my point.
Yeah, you're both on the same side here. Actually, that's why I was asking for the point. You are on the same side already. So anyway,
There, if you look in the side chat, that's the how you calculate the gravitational acceleration of a body.
well, the fun thing about that made up calculation is that you can replace large G with anything you like. It'll still work. Replace it with 1.0 if you like. It's like 6.67 now, right? Is that still the latest number? Used to be
Yeah,
666.
6.67 times 10 to the negative. I
Yeah.
got no idea. Some small
Right.
number.
Right. Codata. So anyway, you can take that number and shove it basically. Change it into anything. The whole thing works anyway. So it's all bull.
It appears we're standing on the shoulders of liars. Anyway, the photos are fucked and manipulated. Clearly. Sexy
Maybe.
Vegan, I suggest you look at Artemis 2, the latest one launched to the moon, and you look at the before and after photo, 12 hours apart, day and night.
Hey,
And you see clear as day and night.
Short
Yeah.
short fuse vegan. Let me give you some. What am I going to call this? It's not advice. It's just it's my point of view on the lying thing. It might not necessarily be that we are standing on the shoulders of liars. We could just be standing on the shoulders of tradition people who believed the story they were told, and they are genuinely still believing it, and they're not
Yeah,
influencing.
this
They're
would
not
be no
influenced.
different to we need meat to be healthy.
Yeah.
Stupid kind of shit like that, yeah.
So anyway, it's I think it's all tradition. I don't think if there are people today that are like actively lying and know the truth, I don't know who they are. I think the majority of people are just following tradition. Their parents told them they lived on a ball, and their parents told them, or whatever, school teachers, third grade or whatever. So there it is. Hey, Morvis, you're hot micing there a little bit. But yeah, we get the question quite often: why would they lie? So
Yeah, and that's still a big question. That's still the biggest problem I have with flat Earth, to be honest. It's not the calculations, not all that. It's just the width of the lie.
yeah, but if it
It's
is just tradition, then you can understand that nobody's lying intentionally anymore. Maybe they did do that 60
yeah, but
years
a
ago.
handful of people, at least, at minimum, a handful
Maybe.
of people
Yeah, but
must know the truth.
maybe, but we don't have the names, so it's kind of hard to confront them about it.
And just the other, like the smaller lies in proximity to the big lies, like let's say satellites, astronauts, those who claim they've gone to space, their relatives, if so be,
Yeah.
all the space program, all the businesses around these things, like all that
Well,
shit.
once you hang around the community a little bit longer, you're gonna get explanations for all of that are you gonna be perfectly fine with. We can talk about GPS and astronauts and things like that. Um, if you're interested. But there is like you have only scratched the surface right now, pun intended. There is so much stuff you need to learn about if you want to really get into it. Like there's something called Snell's window.
What?
Yeah,
Snail's window.
Snell's window. You can Google it. It's kind of the circle of light.
No.
When you dive into a lake and you look up through the water, you're going to see everything as a circle. It'll be kind of dark. You maybe Google it and see it. It's difficult for me to explain.
Snell's log.
Snell's window. Yeah. Snell's law is something else that has to do with refraction. But Snell's window it's an optical phenomena that you see when you're diving into water and you look up. It looks like you're looking through a circle. Yeah, like a black hole. Like you look through a tube of light. That's just how our vision works. So you were mentioning um, astronauts. Why would they lie to us? I am not 100% certain they are. I haven't been up there, so I don't know what it looks like when they look down. But they could very well be looking at something that looks out like a circle, and they could very well think that the Earth is a ball, even though it's not. So are they intentionally lying? I don't know. There are many things you need to know about. Is all I'm saying.
The Earth looking like a ball would still be explained through, if I go high enough, even on a flat plane. Let's say even the flat plane is infinite, but just the fact that I have limited
Yeah,
view distance.
you have a 360-degree view. That's all you have. So it's going to look maybe round.
Exactly.
You're on a big
Yeah, and I
chessboard.
have a limited view distance. However, if I'm well, then there would have to be an edge, I suppose,
Right.
to
I
see
mean,
clearly.
look, if you have a million miles wide chessboard and you look down onto it from above, it's just going to look like a circle to you because you can't resolve the corners. You understand?
Yeah, of course. My
Yeah.
eyes are not square shaped.
I'm not saying I don't know the shape of Earth. Nobody here is going to claim a shape. We just know that the surface is flat, right? So uh, it's Earth shaped for all I know. Like a lake is lake shaped. Yeah, it's just the floor of of what we call our universe.
Okay, so Snell's window I can try in a pool.
Yeah, you can try it out in a pool. Absolutely, 4 meters down, and you're going to see it when you look up, probably. Or maybe it has to be a little deeper. I'm not sure. I can't remember when I was.
My pool is 3.63 meters deep.
So anyway, that
I can lay on the bottom, but
that could be one explanation of why people who have traveled high up think that Earth is round, but I don't know. It would be speculation. I just want to give some people it feels super weird that there is a small group of people who actually knows Earth is flat and actively lying about it. So I don't know. It feels better to me personally to kind of explain it with they thought they saw this and they interpret it this way, and this is what they're preaching now for the rest of their lives, right? But they could have seen just a flat surface and interpret it as a ball.
so then if the South Pole, then the South Pole must be 360 degrees around the Earth, no?
I don't know anything about that. We don't claim an ice wall or anything like that in this
No,
room.
that's not what I'm saying. But I'm saying if it's flat and the north, I mean the GPS and the compass, it still has to point somewhere.
Yeah, they point to the area underneath the satellites, I guess, but we don't know what's beyond. As far as I know, people have been to maybe the South Pole, right? And I don't know if you can go further. It's a private citizen. I'm sure you can't. People get arrested. It was just a couple of months ago. Some dude in an airplane landed on Antarctica. He got arrested immediately. So I can imagine it's not going to be easy to go and explore further on. Up
Yeah,
north,
no, I
though,
find that fishy as well.
this is what I want to do. I'm from Sweden as well. But I lived in America for the last 20 years, right? So, but I come home every summer, and at some point, I think you could be able to actually go north and see what's up there, because you can pretty freely go pretty far up north in Sweden, at least. I don't know how far
But
you can
that's
go.
not so far. If you look at the map, it's not so far up north.
Right. It'll take a couple of weeks to drive if you take breaks, and I don't know. And in the summers, there's no snow up there.
A couple of weeks in Sweden? No, I could get further in the northernmost part of Sweden in 2 days.
Well, I'm from Skåne, so it'll take me a long time. I don't want to drive 48 hours straight. I want to
Okay.
get some polkagris in Gränna and stuff.
Okay.
Yeah.
Okay.
Have you seen the midnight sun up in Norrland?
No, I haven't.
It's spectacular.
I may go up there in this summer actually for sales, but
Yeah, don't forget, I was not a flat earther when I saw it many years ago. So I didn't take any pictures or videos or anything. But if you are going to go see it, make sure you bring a good camera and maybe one of those mounts that spins around.
why? What am I gonna see?
No, you'll see the sun. It stays up it's going to be over the horizon the whole time. It'll go a little bit up and a little bit down around you. It's a fun experience.
How would that be explained on a flat Earth model?
I mean, you can go to your kitchen table right now and put your hand above it and kind of circle it, your finger, and pretend that this is you in Norrland, right? And then move it a little bit to the other side of the table at some point. Now it's over Antarctica.
Then that would mean that the North Pole is closer to
I don't know the layout. We don't
the
claim
pattern of the sun's movement.
No, I don't think so. It just happens
Well,
to
it
be.
has to be. If it has to be.
It happens to be above that part of Earth at that time for about a month. It does it, right, and then it slowly, gradually circles out towards the south instead. And I'm not even sure out is the right word. It circles over to, is what I would say. And I wouldn't even use the word circle because I don't know the exact path of the sun, but this is just what we observe, right? You can go to Norrland and you can see the sun. Okay, it circles 360 degrees around you. It goes a little up and it goes a little down. There's 4 dips, if I remember correctly. And then that happens for a while, right? Maybe 30 days or so. Lower and lower, and then it keeps going wider and wider out. And after, 6 months, it's going to be completely dark where you were standing. Because it's doing the same thing over on the other side of Earth. But I don't know the layout, so couldn't tell you exactly where everything is at. Well, we also have Sexy Vegan with us in the chat today. He or she says that, why should I trust some random people on Discord? These random people are going to be the first people to tell you should not. Do not trust our word. We have a method. You can go and check this for yourself. It's pretty easy. Find yourself a 10-mile wide lake. Bring a friend. Give them a mirror. If you can see that mirror flash 10 miles away, guess what? Either your friend is over 30 feet tall or water doesn't curve between you. You take your pick. Those are your 2 choices. When you find out that water doesn't curve, then you have confirmed it for yourself. You didn't have to trust us. We just gave you the method. You can also do a laser.
Drop the gavel on him, Judge. He's here to troll. He's just been spurging out in the side chat. All he's got is laugh emojis. Anytime something doesn't suit him, he'll just attack with emojis. He hasn't presented any data to prove null or for. He's got nothing.
Yeah. Well, now he has the method, so if he wants to, he can go and check it out himself.
Ah, yeah, there we go. That says it all.
Yeah, personal observations is the way to go. Am I right? Short fuse vegan.
Sorry, I zoned out a little bit. I was reading my girlfriend's text here. She's claiming that the pictures from Artemis 2 that NASA's posted is not day versus night. She's claiming that it is two pictures taken at the same moment, essentially, just with different camera settings.
Yeah, that's the official story.
So they never claimed it's day versus night, 12 hours apart.
No, they claim it's a few minutes apart with different settings for the aperture, I think, or
ISO settings. So it's how fast the aperture, or how long the aperture holds open for, and how fast it operates. So when they say it's a number 400 ISO, that means the aperture will open for 1/400th of a second. Now they claim the difference between the two images, number 1 is ISO 400 and number 2 ISO 52,000. So that means it's open for 1/52 thousandth of a second. So that's pretty bloody quick. So the sensor basically flicks on, flicks off. What that means, in effect, is less light gets in, so therefore making the image darker.
Okay.
Now, the only problem with that is if you go too fast, hardly any light comes in, and you get other effects happening. Chromatic aberration, you might not even get enough light in to see the image at all. It might be just total darkness. At that speed, and where they're located, technically what they should have seen is all black with a light slither along one side. So I call bullshit on what they say, but anyways, that's just me.
well, I haven't been able to open the picture on my computer yet, but there are reports that it's been edited in Lightroom as well, Adobe Photoshop. So, which, I mean, NASA explains that all the time. Well, we have to do it that way. We just wanted to add some extra street lights or whatever for artistic reasons. But this is apparently it's going to the metadata for Photoshop should be in the raw image on NASA's site, but I haven't confirmed it yet. I'm just saying I would take those pictures or whatever you want to call them with a grain of salt this time.
Yeah.
And shit, I sometimes just grant people, sure, they're real. Yes, it's a picture of Earth. Here you go. Now let's see if we can come down here and confirm it. Let's pick any point on Earth and see if the curvature is there that we see in the picture. And guess what? It isn't. So we can't confirm them. So that's how I know they're fake, right? But everybody needs to do that for themselves. And then we can stop arguing if they're fake or real. We can't confirm them down here. So obviously they're fake. I mean, you show me a picture from a satellite of a unicorn in my backyard, and I look out through the window and it's not there. Then I know the picture is fake. You show me a picture of Vättern curving, and I go to Vättern and I don't see it's curving. Well, I'm going to have to assume the picture is fake. Context for new listeners, Vättern is a big lake in Sweden.
Yeah, it's very tall, or yeah, tall and deep as hell, deepest lake in Sweden, but it's very elongated.
Yeah, a perfectly flat lake in Sweden. Big and deep.
It appears so, yes, at least from Jönköping.
Good. Yeah, that's great. Good for you. Hey, let me give you some advice about the girlfriend there. Have you told her yet or no? Be careful because they freak out.
Told her
The
what?
women. My wife freaked
Told-
out when I told her.
Yeah, that's no problem at all.
All right. That's good.
Whatever happens, happens.
Yeah. You got to break it to them slowly. Next time you see the sunset, you say, "Hold on to something, honey. We're falling over backwards. The earth is falling over backwards. 1,080 miles per hour. Hold on."
Okay, I'm
That's
not, I'm
why.
not that sold. I'm not that sold yet.
That's why you see images of people sitting down at the beach enjoying the sunsets, because they know they're falling backwards and they need to stabilize themselves.
Right. Speaking of family, I gotta go watch the Willy Wonka with the family. Talk to you guys later. It was nice talking to you.
Catch you, mate.
Have a good one. Thank you. You too.
Thank you.
Farewell.
Yeah, farväl.
See you around, boys.
Right, so there's a couple of names I don't know. Yo-Yo, welcome. What have I got? Is it Ilina? Ilina? Not sure. If I've said it wrong, please help me out. I sound like I can speak good English, but I don't really. I'm not good with names.
How are you?
Not too bad, my friend. What brings you in here today?
I'm here to learn.
You're here to learn.
Yeah, to
Ooh.
listen to you and learn with my friends this voice.
To be quite fair, listening to me to practice your English is probably not a good idea.
Why, my friend? Can you help me?
Because my English is not very good.
Yeah, you're right.
Thank you. Because I speak Australian, and Australians are not known for their accurate enunciation or pronunciation of a particular words. So if you want to speak the lingo and sound like an Aussie, then listen to me. If you want to learn English and speak correctly, then yeah, good luck. But anyways, my friend, yes, we are on the English Hub, and this is the 24/7 Flat Earth Discord channel. So how about you have a guess what we normally talk about in here? It's in the name, bro. I know it sounds complicated. No, he's bailed out. Oh well, we've also got Bridge. Who else have we got hiding in the background other than the usual troublemakers? Who is CR? Oh, CR is headphoned. Jacka is back. There's not much music going on at the moment, mate. But if no one wants to talk, I could probably squeeze a tune in. I don't think anyone would mind because we've got some of Drace's really cool stuff. Alright, I might just play a song. I'll just go and fetch one. That one right there. So we'll play this, and then we'll see if anyone wants to have a chat just after. Oops, messed that up. Or the bot might just not work. That's alright. We can... This thing hates me. It was going so well yesterday. All good for a couple of hours. Well, the soundboard is going to make up with how I feel about this music bot.
Don't make me hurt you.
That says it all.
You drag the spotlight off the point and toss it down the hole. Start talking stick, shadow, stars, anything at all. A trail of shiny nonsense that you swear is relevant, but your detours only show you've got no evidence. I chase you once, I chase you twice, then I just stop the chase. Your breadcrumb trail's a map of how you run from what you face. You can't distract a mind that's built on measurable reality. Your tricks dissolve on contact with a little rationality. I'm a critical realist fortress, you're a whisper in the wind. conversation never stood a chance to begin. You hold your premise like evidence and deny conclusive proof, as if repeating something louder makes it any more true. Because it is, you chant a loop that never ends, a serpent swallowing its tail and thinking truth's a trend. If logic were a test, you'd fail the multiple choice, but somehow still declare yourself the loudest, highest voice. You can't distract a mind that's built on measurable reality. Your tricks dissolve on concentrate this kind of mind. You had me cornered with that rhetorical parade. Cute, I've seen more solid reasoning, a late night lemonade debate. You juggle fallacies like fireworks, hoping I'd be impressed. But I read your moves like textbooks titled How to Fail a Test. You can't derail a truth that's grounded deep in observation. Your logic leaks like faulty pipes beneath a shaky foundation. I'm an empiricist logician, evidence is my domain, while you're red herring through the ruins of arguments you stay in. When your tactics crumble, don't look shocked they didn't land. You can't outwit the laws of thought with nothing but an empty hand.
Oh, welcome to those that just dropped in. I'm guessing by the fact that everyone is staying quiet that yous enjoy listening to Drace's songs. Please someone give me a thumbs up or anything. I've got no problem playing another one, but I just don't want to hurt someone's feelings when they're sitting back going, nah, this is crap. Nice one. That's funny. Alright, we'll grab another tune. I'll just go to the little vault. So that was Measurable Reality. Let's go to this one, Cognitive Edge.
I don't talk loose, every word calibrated. Clarity is strength and confusion's overrated. Logic ain't truth, it's the system that tests. Valid isn't sound, only facts make it bless. I'm a craftsman of thought, not a slave to the spark. I build my conclusions while others strike in the dark. Philosophy's a toolbox, not gospel, not myth. I pull out the concepts that sharpen my drift. I keep a cognitive edge, razor built reasoning. Impulse tries to jump, but I don't let it seize me. Sound over valid, check the premise, check the claim. I don't bend for emotion or the weight of the frame. Self-mastery's the engine. Discipline's the proof. Precision is the shield that guards the pursuit. Frustration's just feedback. I process the spike, strip it to the root, analyze what it's like. A feeling's not a verdict, I don't take it as law. I check the interpretation, break it down to the raw. Truth needs structure, that's the nature of fact. A mind without order stays forever off track. No drift, no chaos, no sloppy design. I run my cognition like a blade to the spine. I keep a cognitive edge, razor bill reasoning. Impulse tries to jump, but I don't let it seize me. Sound over valid, check the premise, check the claim. I don't bend for emotion or the weight of the frame. Self-mastery's the engine, discipline's the proof. Precision is the shield that guards the pursuit. Every thought has a lineage, trace it back to its root. If the premise is rotten, the logic won't compute. Philosophy's a structure, not a throne to defend. It's a method, not a doctrine, not an ultimate end. Reason is intention, not a vibe, not a guess. It's a choice, it's a temperament forged under stress. I keep a cognitive edge, razor build reasoning. Impulse tries to jump, but I don't let it seize me. Sound over valid, check the premise, check the claim. I don't bend for emotion or the weight of the frame. Self-mastery's the engine, discipline's the proof. Precision is the shield that guards the pursuit. This is deliberate design, not fate, not chance. A philosophy of action, not ornamental stance. Truth demands structure and structure takes skill. I don't wait for clarity, I forge it by will. This is Dre's intent sharpened, cognition defined. I don't follow the moment, I architect the mind.
Well, there you go. Andres X17. Welcome. Now he doesn't want to talk. Or are you just happy to listen also to those cool tunes? Looks like I'm playing the next one. What do we got? Cosmos in Crisis.
Good afternoon, Matrix.
Afternoon. Welcome.
How you doing?
I'm going alright. Just playing a few of Drace's excellent songs. And it looks like a few people just want to listen in and relax, so they get to hear my little bit of commentary in between each one. Patiently waiting for good people to pop in and tell us how they believe they live on a globetard. But other than that, just feet up, chilling, relaxing on this awesome Sunday.
I was talking to some people I play games with today about the flat Earth.
Yep.
And every time they use these words. What do you believe the Earth is? They always say believe. And I told them I don't hold beliefs on objective reality. And then he literally said, gravity is objective reality.
Oh. Did you grab him by the back of the pants and throw him into this room? So he can repeat that
No.
out loud in front of everyone?
I ignored him because they say that stuff and then they say that I'm rage baiting them.
It's because they don't know. Because they've all been indoctrinated with the same law. So when you've got groups of them like that, they will all reinforce each other with the same stupidity. That's why it's easier to peel them away from the pack, explain stuff to them, give them something to think about, and then send them on their merry way. But yeah, it is interesting how they say, do you believe? It's always, do you believe? Do you believe the moon is real? And it's like, huh? That thing in the sky at night time. Crazy stuff. But anyways, mate, I'm going to chuck another song on. And I'm not really going anywhere, so we'll see how this song goes.
I'm standing on the ladder of the cosmos, hear it creak, first wrong whispering, your assumptions are weak. Built a model on a guess on a dream, then passed the hose with dark matter just to make it all seem like the numbers align, like the curves all behave. But the data keeps yelling you misread the wave, galaxy spinning out wider than the math will allow. If the base ain't right, then the tower falls down. We keep painting over cracks with a parameter tweak, but the ceiling keeps sagging and the future looks bleak. Check the premise, check the ground, check the bedrock below. If the shape of the earth ain't right where you think you gon' go, yo, the cosmos is in crisis, foundations unstable. We got runaway theories holding up the table. If the first step's wrong, then the heights might crumble. Even giants lose balance when the roots start to stumble. Crisis, yeah, it's crisis in the sky. Rebuild from the bottom of the stars, my life, yeah. We measure out the heavens with a ladder full of bands. Each room built on assumptions that we treat like friends. Photometric redshifts playing tricks on the view. Distant galaxies look ancient, but the numbers ain't true. Simulations getting praised for a match they don't earn, cause the subgrid physics fake it with a well-tuned burn. Black holes too early, but we call it profound. Maybe we just dropped the ruler on uneven ground. We keep adding new patches, trying not to confess, but the tension in the Hubble rate is showing the stress. Check the premise, check the ground, check the axioms phase. One false move and you distort all the space. Yo, the cosmos is in crisis, foundations unstable. We got runaway theories holding up the table. If the first step's wrong, then the heights might crumble. Even giants lose balance when the roots start to stumble. Crisis, yeah, it's crisis in the sky. Rebuild from the bottom or the stars might lie, yeah. From the curvature debates to the lights in the night. If the Earth's first premise ain't precisely right, how you trust every ladder we extend to the deep? One weak link in the galaxy's lead, beyond all prediction, defying the plan. A cosmos in crisis starts with how we begin. No wonder the universe is breaking apart when the cornerstone cracked at the very start. We can't heal the heavens with a patch on the seam. Gotta reforge the foundation if we want the dream. Check the first rung, listen close when it breaks, cause the whole sky shakes with the smallest mistakes.
Oh, someone just popped in. Welcome. I don't even know who it was. I'm just that used to saying it now. And then counting to 10 seconds, and then dum-dum when they run away. Which is really sad. Well, new person. At the moment we're playing Drace AI's music. Dow Duo. I probably said that wrong. Made an absolute dog's breakfast of it. But anyways, that's the what we're doing at the moment. unless you want to bring up a Earth-related subject or issue, or maybe even a proof if you think you live on a ball. Because that would be fantastic. And I'll take your silence as a no. So we shall go back to listening to more songs.
To the scholars on the globe side, I'm addressing you direct, not to challenge your conclusions, but to tighten the respect. In the field of observation, every model must align, not with faith in old assumptions, but the data we can find. This is not about conversion, not a battle to be won, but a method of inquiry grounded in what light has done. Before we set up any late test, let the evidence decide. Walk with me through optics, let the wavelengths be our guide. Before you trust a model, take a moment, take a view. Let the cameras and the spectra tell you what the air can do. Infrared against the visible, to pass through the same sky. Show the bending and divergence, no equation can deny. Look at all the world-read images the internet has stored. Analyze the color drift before any test is scored. This is not about believing what another voice implies. This is just a simple call to open up your empirical eye. Every long distance photo, every skyline, every shore carries signatures of optics you might not have seen before. When the air is shifting density, when the ducts and layers rise, white light isn't uniform, it fractures subtle in disguise. Infrared may mark a boundary, visible may reach beyond, but the difference in their horizon shows the medium they respond. If a distance breaks the limits of the geometric sphere, check the wavelength separation, see what physics makes appear. Before you trust a model, take a moment, take a view. Let the cameras and the spectra tell you what the air can do. Infrared against the visible, to pass through the same sky. Show the bending and divergence, no equation can deny. Look at all the world-read images the internet has stored. Analyze the color drift before any test is scored. This is not about believing what another voice implies. This is just a simple call to open up your empirical eye. You don't need to change positions, don't need theories in advance. Only treat the data fairly, give the evidence a chance. Study how the lower edges shift their contour with the heat, how the waterline distorts when refractive gradients meet. This isn't globe or flat, it's the discipline of sight. Letting spectra write the narrative in the presence of the light. So before we build the setup, before we measure lake and sky, start with what already's captured, let the photographs reply. I'm not asking you for trust, I'm not asking you to bend, only asking you to question how the wavelengths comprehend. Let the optics speak their language, let the evidence extend. This is just the first foundation.
Y'all are allowed to talk about how good his songs are too. Like, they are super chill. I can't deny that. Actually, we've got quite a few talented people that are putting tunes together. Some of them using AI, some of them not. Credit to those that don't. Like, because it's some pretty talented stuff, man. If you're just thinking that stuff up and then writing your own music with it, the likes of Flatloyd, right? I know Drace does bits and pieces of his. Kembo Beats we haven't seen for a while, actually. It's starting to concern me. There's quite a few. Doog, he's pretty handy at slapping a tune out. Actually, I'll play Logical. I'll play one more from Drace because that's the last one of the album, and I'll put that one on because it's a pretty cool song, actually.
Was that last song from Drace?
Yeah.
He's got a good voice.
No, it's not. I don't think it's him singing.
Oh, okay.
They say the crown is just a symbol, but symbols don't marry cousins for 1,000 years. So let's talk about it. Yeah, out it. Yeah, blue blood, red carpet, white lies in the palace. Every throne built on secrets, every oath built on malice. Dynasties keep it tight like a vault with a chalice. But who they tryna hide from? Why the centuries of silence? Marrying their nieces saying purity's tradition, but purity ain't biology, that's a power superstition. Claiming heaven sent the lineage, divine right commission, but that's just ancient PR for generational ambition. Got 1,000-year echo in the marble of their halls. High priest, blood priest, shadows walking through the walls, talking we protect the order, but the order looks like fear. If your blood is so holy, why you keep it so near? Light of the crown.